to Tokenized RWA Bootcamp. My name is Andre. I'm one of the developer relations engineers here at Chainlink Labs. As you already know, feel free to drop in a chat where are you tuning from, or simple GMs, so I can know that you can clearly hear me. So yeah, I see people tuning from France, Poland, Boston, Paris, Egypt, Luxembourg, wow, Argentina, what else? South Africa, Vietnam, wow, USA, well, let's see, India, Mars, okay, that was funny. What else? Pakistan, Venezuela, Nigeria, okay, Belgium, great. We're tuning Turkey, we're tuning from all around the globe, Cameroon, Philippines, Colombia, Portugal. Wow, I'm really impressed. Indonesia, Chile, great. I'm really impressed. Welcome everyone. So my name is Andre. As I said, I'm gonna quickly drop the URL for the Gitbook for this bootcamp. As you already know or familiar with our previous work, we store all the like learning material in these Gitbooks. They're publicly available on the internet, so you can just follow along throughout the course. So this is the URL, cll-devrel.gitbook.io/tokenized-rwa-bootcamp-2024. So I'm gonna quickly, in a minute, start sharing my screen, and we're gonna go step by step throughout the instructions in a Gitbook, and this is how we're gonna roll. Also, if you have any questions, feel free to drop them in a chat. I'll try to answer them live on stage, or we have Richard Gottlieber, my colleague, another developer relations engineer for Chainlink Labs in background, who is also gonna try answering your questions while I'm talking. Okay, cool. Let's share my screen actually, and we can start. So we are gonna share the entire window actually. Okay, cool. So you should be able to see the first page of the Tokenized RWA Bootcamp. And in the setup instructions, we said that you need to have MetaMask installed or wallet of your choice, GitHub profile, because sometimes it's needed as an authentication method for our faucets, to get testnet links or testnet ETH from Ethereum Sepolia, and to join our Discord. Well, plans changed a bit, sorry about this, but if you go here, you can see that gas prices on Ethereum Sepolia have been like ridiculously high for the past week. As we can see, it's all in red. So unfortunately, we needed to switch the testnet, and we decided to go with Avalanche Fuji because sorry about this. During the CCIP bootcamp, we also used Avalanche Fuji as our source blockchain. So we assumed that you had some Fuji already. But if you don't, you can click on this link. I have a typo, should be AVAX, not ETH. I'll fix that. But you can go to faucets.chain.link, connect your wallet, and you can see that already 25 link and 0.1 AVAX Fuji are selected, and that should be enough for you to follow during the bootcamp. The nice thing about this faucet is that you can switch wallet addresses or receivers. So I can put my other wallet address here, smart contract, whatever here. And if you have AVAX, if I drip this, then you can just get tokens, but links. But for AVAX, there is this GitHub authentication method. So that's the reason why you need a GitHub profile, but I assume you already have one as well. This is a good question, actually. Can I use any other chain as well? Yes, you can use other testnets, but I'm going to do it on Fuji. So yeah, technically yes, or you can just simulate in a local environment if you want. Can someone share the Gitbook link? Well, yeah, it was right over here. I'm gonna bring it back. Okay, cool. So this is our Git book. Okay, let's start. So welcome to Tokenized RWA Bootcamp. This is our second intermediate bootcamp in the past period. Again, as for the CCIP bootcamp, there will be a certificate of completion. It looks like this. It will be required for you to complete some homework to get it. Homework won't be that hard as for CCIP bootcamp, don't worry. Basically, the one thing that you need to do is to just redeploy all of these 3 exercises, and that'll be enough for homework. So, but enough of homework. First of all, let's go with the curriculum. So today we're going to talk about a bit about theory, about real-world assets, about challenges with tokenizing different real-world assets to different blockchains, and how Chainlink can solve those issues and those challenges. Then we're gonna have this exercise number 1, where we are gonna create a cross-chain mocked real estate. We're not gonna tokenize the actual real estate. We're gonna use Zillow's API. They have like one of mock instance. Address is literally in the middle of oceans or something, so it's like a mock thing. But we're gonna tokenize that real estate, and we're going to make it cross-chain, and we're going to automate it. We're going to see for various reasons why. And then during day 2, we're going to use that tokenized real estate, mock real estate, and implement various different use cases using it. So the first use case will be to create RWA lending platform or protocol where you can lend a fraction of your real estate and get USDC in return. And the second use case, we're going to create an English auction where you can sell a fraction of your tokenized real estate tokens in exchange for a native coin on Avalanche Fuji. That'll be AVAX. So these 2 will be our use cases for tomorrow. But obviously, these are just 2 use cases. Much more can be built once you have a tokenized real asset on chain, and these 2 use cases to actually inspire you. What more can you build, rather than like show you exactly how to build it? Because again, we're going to have like a mock real estate, not the actual one. I didn't want to tokenize my house, for example. And we're going to have guest lectures, guest talks throughout the both days. So today we're going to have a talk with Limpid team, and tomorrow we're going to have a talk with Bricken team. Speaking of homework, we'll be just redeploying these 3 exercises, contracts from these 3 exercises, and you're gonna just send us your addresses, like URLs to the Block Explorers, and like from Block Explorer we can see a bunch of transactions. So I'm gonna basically go through transactions, and that's like a proof that you not just deploy the contract but actually perform the exercise on chain. So that'll be needed for you to get this certificate of completion. Okay, cool. Before we start, how you can be connected with us. So you can subscribe to Chainlink Developer newsletter, where you can receive emails about any future bootcamp that we might have, and also about any new updates from the Chainlink ecosystem. Also, you should follow our Chainlink official YouTube channel, because this video is currently live on demand, but it'll be available as soon as we start recording it as a recording on Chainlink YouTube channel, so you can always rewatch it at your own pace, faster, slower, skip this part if you're not interested in it, etc. And finally, you should join us on Discord, because we have a dedicated bootcamp channel on our Discord server where you can ask questions. Just don't forget to tag me. I'm Andrei Chainlink Labs. You'll see people already tag me a bunch of, so I don't miss that notification, and I'll make sure to answer you as soon as possible. Also, we have a couple of new events regarding real world assets. So on October 15th, we have the webinar for solving the data problem for tokenized RWAs. And if you click on this URL, you can register for it, and you can see we have speakers from the network firm and Chainlink Labs. So don't if you're interested in real world assets, don't forget to sign up for this. And this bootcamp is going to be medium to advanced. But if you're a beginner, or if this is too hard for you, or this is your level, but you have a friend who wants also to join the space, in November, late November, from November 18th to 21st, we're gonna host another blockchain beginner bootcamp. So this is for beginners, blockchain beginner content. Register here, and you're gonna learn basics about EVM blockchains, smart contracts, and Solidity programming language. All the prerequisites needed for this bootcamp. So if you're not sure, you can always join this bootcamp. If this is your pace, then you can always recommend someone to join it, because, as I said, this is going to be a medium to advanced bootcamp. And finally, if you're just interested in in-person events, if you click on this URL, you can find all the upcoming events hosted by Chainlink Labs, in-person and virtual, language even, like, and different type of events. So yeah, you can always be up to date with where are we, and if we are in your town or in your country, you can even come to in-person event. Finally, we have SmartCon. As you already know, SmartCon is approaching. This is our developer conference on October 30 and 31st, so a month from now. This is a conference where TradFi and DeFi will meet together. So don't forget to register either by clicking this URL or scanning this QR code. It's safe. And also, 2 days before the main event, there will be a hacker house. So you can click on this URL or this link to register for hacker house, which is an event crafted specifically for developers. As I said, 2 days before the main thing. SmartCon is going to be really interesting this year, and we can see some of the past SmartCon speakers. Pretty important names from our tech industry. Okay, cool. So finally, about your instructors, as I said, Richard Gottlieb, he is in the background answering your questions. Also, Richard helped with creating the content for this bootcamp. You can follow him on Twitter or X. The RGDev is his handle. If you click here, well, there he is. I already follow him. Yeah, I follow him. So follow Richard, or you can also email him at richard.gottlieb@smartcontract.com. For myself, I'm Andre_dev on Twitter. This is my email address. You can also follow me, and you can also follow my where is that? Yeah, my newsletter. So I'm writing this thing. Smart Contract Design Patterns is a newsletter about smart contracts and Solidity in general. So you can just click on this URL and subscribe, because I'm gonna drop a new article pretty soon about digital signatures, and also about using the Chainlink data feeds for production ready apps. We're gonna cover most of that during this bootcamp as well. But if you want to have like a nice guide, you should subscribe to Smart Contract Design Patterns. And that's it. Now we're starting. Let's see if we have any questions. Oh, this is a good one. Will we be able to add RWAs to music as a digital asset? So for this bootcamp, we're gonna tokenize real estate, but that's definitely possible, and I'm gonna talk about it in a minute. And yes, this video will be recorded to watch later. As soon as this live stream ends, it'll be appear as a recording on Chainlink YouTube channel. So no worries. Okay, cool. So what are real world assets? So by definition, real world assets in blockchain are digital tokens that represent physical and traditional financial assets, such as currencies, commodities, equities, and bonds. But they're really powerful because you can tokenize even more of these digital goods, like real estate, like your precious painting or any art or a watch or a music, as we said, and earn royalty out of it and whatnot. So as we can see here, the physical assets that can be tokenized varies all from cash, commodity, equities, whatever I said, to artwork and even intellectual property. So you can tokenize your IPs. And the tokenization of RWAs marks a significant shift in how these assets can be accessed and exchanged and managed. Because now we'll move them on-chain so you can trade them on the blockchain 24/7 without any restrictions. And this unlocks an array of new opportunities for both blockchain-powered financial service and wide variety of non-financial use cases, as I said, artwork, for example. The three main benefits of tokenized assets are liquidity, transparency, and accessibility. So, because again, by putting these assets on blockchains, blockchain networks, which can interact with each other. So, because of CCIP, you can just tokenize your real-world assets on one chain, and then using CCIP, you can move it throughout different chains, from private chain to a public chain, and vice versa. Also, because tokens are represented on chain, there is natural transparency that goes with the blockchain technology itself, and accessibility, because you can trade from wherever you want, whenever you want. It's on chain. It's just a matter of submitting a transaction. There is no like thing as like, oh, our trading platform works until Friday 5 p.m. whatever. So like blockchain unlocks this for us. But important thing is, okay, real world assets are cool, but how we can bring them to chain in the first place? To do that, there are 5 different steps. And I'm going to go through each of these steps from the perspective of our example, of our mocked real estate. So first of all, we need to select an asset, the real world asset that we want to tokenize. As I said, again, cash, bonds, commodities, artwork, IP, real estate, music, whatever. We're going to tokenize that mock real estate from Zillow API. Then you need to specify a token. So you need to determine the type of token, whether it's going to be non-fungible or a fungible token, or even both. So there are different token standards in Ethereum and EVM chains. ERC20 stands for like the most basic non-fungible token. ERC71 is a fungible token, but for this, and if you remember our workshop from Chainlink Block Magic Hackathon, we use ERC71, but for this bootcamp, we're going to actually use ERC1155, because this token standard allows us to represent non-fungible asset with certain amount of fungible tokens, meaning that we can fractionalize our real world assets. I'm going to talk about that in a minute. Then blockchain selection doesn't really matter that much if you create your token to be cross-chain powered by CCIP, which we're going to do. That means that you're going to just issue your token on one blockchain, and it can persist in that ecosystem. But if you make it cross-chain, then you can just send it to all other CCP-powered blockchains, transfer between non-EVM to EVM blockchains, between private and public chains, and whatnot. So, like at that point, you don't really care about the blockchain, because you can swiftly move it between chains. Off-chain connection, that's one of the most crucial parts. So most tokenized assets require high-quality off-chain data, and Chainlink is the only platform, the only blockchain services platform that can provide you both data, computation, and cross-chain stuff. So with Chainlink proof of reserve feeds or Chainlink functions, you can grab all of these data, and we're going to use Chainlink functions to get the various different data about our real estate, like number of beds, years built, and whatnot. And we're also going to use Chainlink functions to get the details about the asset price in the real world. And using some math formula, we're going to calculate it on chain, but that's for day 2. And finally, issuance. You need to deploy these contracts, you need to mint them, and making them available for usage. So this 5th step is out of the scope for this bootcamp, because it's not a technical problem. It's more like a different type of problem. Like you need to be able to prove that Alice owns this real estate in real world, and what happens if Alice wallet got hacked? Like, will she like lose, if she loses the tokens that represent her real world asset and whatnot? So for the sake of this bootcamp, we're gonna just create another smart contract issuer, and through that smart contract, we're just gonna mint that mocked real estate to Alice address, and we're gonna leave it as is for now. But more about this fifth step you can read in a Chainlink blog post. So again, this is out of the scope, a bit out of scope for this bootcamp. Now, types of tokenized assets. Well, there are different types of tokenized assets, and you might think that, yeah, this is a great technology, this is a great idea that can unlock a bunch of use cases, but like there are not like real world assets currently on chain. And if you think that, you'll be wrong, because there are currently real world asset projects on chain, and I bet you interacted with one of them at least. But before we start with that, there are three different types of, so you need to be, so depends on asset location, collateral location, and backing type. So it can be on-chain or off-chain assets, can be on-chain or off-chain collateral, and it can be direct backing or indirect backing, aka you have like a synthetic version of that real-world asset. And if I scroll down a bit, you can see that there are different real-world assets in production already. So for example, wrapped ETH, I assume you interacted with it, at least if you paid for CCIP fees in native coin, you interacted with wrapped ETH. So that's on-chain asset, on-chain collateral, direct backing. So you have ETH, there is a smart contract, you locked ETH in that smart contract. So on-chain asset, on-chain collateral, and then the smart contract will mint you the exact amount of wrapped ETH token. So that's like direct backing, one-to-one. Then there is wrapped Bitcoin, on-chain asset, but on-chain collateral, but indirect backing, synthetic asset, because that collateral is on a Bitcoin blockchain, but we move it as a synthetic asset to Ethereum blockchain. So it's a wrapped Bitcoin. Example of on-chain asset, off-chain collateral, and direct backing will be a wrapped BTC ETF. Example of on-chain asset, off-chain collateral, and synthetic version will be wrapped BTC ETF that represent an ETH ETF, for example. Hypothetical example of off-chain asset, on-chain collateral, and direct backing will be a stable coin backed by other stable coins. And if we talk about stable coins, example of off-chain asset, on-chain collateral, and synthetic asset backing will be DAI, off-chain asset, off-chain collateral, direct backing USDC. The stable coin we're going to use for this exercise, for exercise number 2, sorry. So tomorrow. And finally, off-chain asset, off-chain collateral, and indirect backing, like synthetic version, is USDT Tether. So you can see that real-world assets are already in production, and probably you interacted with at least one of these. Our goal for today is to go beyond tokens, like non-fungible tokens, to tokenize something fungible, which is a real estate. So how tokenization works and what tokenization is. So definitely with the potential we have with tokenization is one of the most ambitious blockchain use cases and can unlock a lot of other use cases if done right. So let's move here. So tokenization in its assets involves creating a digital representation of an asset. Real world assets, like we mentioned, artwork. You can tokenize your, I don't know, coffee shop if you own it, or a house or whatever, and then use it maybe as a collateral to get a DeFi loan or whatever on chain. Three main benefits, as we said, is like it allows you for real-time settlement, like 24/7 trading, because everything's on chain. You can just use it. There is liquidity. There's obviously reduced cost because tokenization significantly lowers operational costs in financial markets by streamlining the process and eliminating the need for multiple intermediaries, because everything's happening on chain, blockchain as a technology, and cryptography is enough to unlock a bunch of different use cases on chain. And tokenization broadens types the assets available to investors, enabling them to participate in asset classes that were previously inaccessible or challenging to enter. AKA, you can now trade and enter this field from wherever you are. It's much easier. And of course, it comes with enhanced transparency because of the native of a blockchain, blockchain technology itself. And as an examples, we cover mostly stable coins, but can be debt, real estate. We're going to do commodities, artwork, music, as someone mentioned. So this is, you can read about music, and finally, gaming. So how to tokenize the asset? This, I think, this image sums it good. So on the left side of the image, there are like real world assets in the actual world, and then once you tokenize it, you can use it in DeFi or like you can use it in DeFi use cases. Like that owning a real world asset token can prove that you have enough leverage to get a loan, for example, or stuff like that. And tokenized real world assets are like can be verified by Chainlink proof of reserve. So, like using Chainlink proof of reserve, you can get the price of that real world assets instead of like calculating it using the math formula, which we're gonna do for this bootcamp, because again, we are tokenizing a mock real estate. There is no really a Chainlink proof of reserve feed for a mock Zillow API, but like projects that have proof of reserve feeds already in production in Chainlink ecosystem are like TUSD, Pawn Token, platform like OpenEd and Cash Gold and Bridge Tower Capital, and all of these. You can just, if you click on these URLs or you go to the Chainlink proof of reserve feeds on documentation, you can see all of these different proof of reserve feeds that, again, you don't need to tokenize them. You can just use them for your use case. You can create a use case for lending and borrowing, for example. This is pretty much a way how you can create proof of reserve feed by selecting asset to tokenize, define token type. We're going to use, again, 1155. Once we choose a blockchain where we're going to deploy it, you need to select third-party auditor to verify offchain asset, and after that point, you can have a Chainlink proof of reserve feed, and you can just use it in your use case. So again, this is a bit beyond this bootcamp because we cannot have like a feed for a mock real estate, but this is how you will do it in practice. And Chainlink Labs team is definitely here to help you. But before that, there are 3 requirements of tokenized real-world assets. So you need to have like fully benefit of real-world asset. That real-world assets need to be enriched with real-world information, be securely transferred to cross-chain, and connected to off-chain data, regardless of which chain they're moved to. That means that, first of all, real-world information. In our example, for real estate, like prices, tax assessed value, number of bedrooms, images, year build, like year of first sold, year of second sold, whatever. Like a lot of real world data that we can consume using Chainlink functions. Then it needs to be blockchain agnostic. So, like if you're on chain A and you want to trade with someone on private chain B, you can't without CCIP, because you need a secure way to connect between these 2 chains. So your tokenized asset needs to be supported with CCIP, and then the rest is pretty easy and self-explainable. And connect off-chain data regardless of which chain they're moved to. So that means that if you need to update token metadata, again, Chainlink needs to be present on that chain to provide you off-chain data, and Chainlink as a platform is there. So you can see here that how Chainlink can help you with step number 1, with providing the real world data. So first of all, with proof of reserve feeds, which we talked about it during the previous couple of minutes. Then with identity. So if you need identity data of of counterparties or asset owners, then there is a service called DECO. So DECO is the service by Chainlink Labs, which is basically a privacy-preserving Oracle protocol that utilize zero knowledge proofs and zero knowledge technology. Not live in production yet, but there are some tests ongoing, and you should hear about DECO a lot in the upcoming period. But essentially, it because of the usage of ZK technology, it allows you to prove identity of counterparties and asset owners on chain. Then data streams and data feeds, different types of data that can be provided to you either by push or pull Oracle mechanism. And finally, functions, which allows you basically to connect to off-chain data using at the moment JavaScript as a language, but it will be expanded to more languages, of course, in the future. And you can create push requests, get requests, calculate all the different computation and whatnot. So we'll see that in a minute. Not finally, but as a step number 2, once you have all of this data and you have a tokenized asset, it's really important to be a cross-chain token, because as I said, like, you want to be on a chain where the trades are happening, or you want to be on a chain where this use case A or Z is enabled, like a lending protocol, for example. So with CCIP, you can easily move your token, your tokenized asset there. And finally, you need to keep your tokenized assets updated. So as they move, we are cross-chain to different chains, or as they're like different update in a real-world asset, you need to keep them updated. And with the Chainlink platform, you can do that, because again, there is CCIP to move chains, there is functions to update the metadata by consuming the real-world data. There are different types of feeds, proof reserve feeds, data streams, which you can consume the various type of data, specifically prices of that token on chain for various different types of assets in real time. So that's something called maintaining the golden record, because like as you move the real world assets, it's constantly updated and constantly up and running and live 24/7. So like, I don't know if you remember like financial crisis in 2008 in Greece, where people were like not able to withdraw their funds from banks. Like, that's not possible on the blockchain world, essentially. So the only platform that has all of these features is Chainlink. Chainlink can give you data, can give you computation, and can give you cross-chain. And using Chainlink platform, you can tokenize whatever you want, and identity with DECO. So yeah, this is what the Chainlink platform is all about. And now we're gonna get our hands dirty, because we are gonna start building our example. Okay, cool. Sorry about this. For this workshop, we're going to create tokens that enable the tokenization of a mock real estate. And for token standard, we chose ERC 1155. Why? Because with ERC 1155, for each ID, there is non-fungible part. So by calling URI function of particular ID, you can grab all the metadata about an asset. In our case, that'll be image, real estate address, year built, lot size, square feet, number of bedrooms, and all that stuff. But also for each ID, you have like the fungible part. So for example, for our real estate, we can mint 20 fungible tokens. And like basically you have like 20 tokens for a same token ID for a same fungible asset. And that means that like those 20 tokens represent 100% of ownership of that asset, and it's immediately fractionalized. For example, with ERC 71 standard, you have like one ID, one token ID, one non-fungible asset, and you need to transfer the whole thing to a different address or a smart contract or whatever. But here with ERC 1155, you can have fractions. You can also have like one fungible token, and that's like one token for one non-fungible asset, like pretty much the same thing. But if you mint more, that means that you already fractionalize it to, in our case, 20 different pieces. What that means is that if Alice sends 5 of these fractionalized tokens, 1155 tokens with ID or whatever to Bob, that means that Bob now owns 25% of this non-fungible asset, like this real estate asset. So you're not transferring, you're not transferring the NFT part, although there is an NFT part, you're just transferring the actual fungible tokens. I hope that makes sense. If it does not, ERC 1155 is like a really powerful standard. It's been in a space in a while, so you can always go to, you can just Google it, go to the AP and read more about it, and reasons why we chose it as our standard for this exercise. For a blockchain selection, we're going to deploy to Avalanche Fuji. The original plan was for Ethereum Sepolia, but again, because of this, we switched to Avalanche Fuji, but it'll be CCIP enabled, so we'll be able to transfer it to Sepolia, to Polygon MI, to whatever blockchain connected to Avalanche Fuji testnet. So it should be pretty fun. And for off-chain connection, we're going to use Zillow API, specifically their mocked API. The reason for that is, well, you can use it for free, and it's a mock real estate, so it's less of a friction points for you to set up and just use it. And we're also going to use Chainlink automation, and we are going to use Chainlink automation to get the details about price of this real world assets on a daily basis. So we're going to constantly call the functions to get new price data and to update them each single day. But more on that later. Okay. Exercise number 1. Yeah. So for your homework, for your first homework, your task will be to just do this exercise by yourself. You'll also have like exercise time, hopefully today as well, so you can just do it here while watching the recording. But also there will be a form to send the address of your smart contract, 2 actual smart contracts needed for this exercise. And basically, we are going to just track the transactions to see that you created a functions request, that you created a function description first, then make a function request, then make another function request for prices, then issue the NFT and all that stuff. So just deploying smart contracts will not be enough. You'll need to do the whole exercise, but I'll walk you through it right now. Okay, so first of all, we're going to call the Zillow API. And if you're not familiar what this API is, you can always refer to Zillow documentation or what Zillow is. But essentially, if you click this URL here, this is the API that we are going to use. This is going to be a free one, so that's why you'll need access token, but it's a mock one. But using this API, for example, you can see what else they offer and maybe think about it for your use case. Then we are going to populate with this NFT metadata, well, property address, year build, lot size, living area, number of bedrooms, etc. And we're going to also calculate the IPFS CID hash of this asset. This is powerful because with Chainlink functions, when you create a request, actually, let's walk you through the code. So if you click on this URL, it will open the Chainlink functions playground with this code. So I'm just going to go here. And you can see it's exactly the same code. So I'm going to just expand this a bit so you can see the full screen. So what we're going to do here is we are going to make an API, HTTP GET request to the Zillow API with this access token you saw on the previous screen and get the mock data of this property. We are going to grab from the API response, from the data pillar API response, real estate address, the year build and convert to number, lot size, square feet, living area, and bedrooms total. So we care about these properties. But if you click here, which I'm going to do, and hopefully you're going to see, let's do it like this. Sorry about this. If I copy this URL, copy and So here, oh, it's open here. You can see here that this mocked API gives you a lot of more data, so you can just play with it and like get images, get I don't know, like a lot of different data. If there is, for some there is like null because there is no park or whatever. But we are interested in these 5 properties. After that, we're gonna form that in a form of metadata. Metadata, like following the ERC 71 standard, because ERC 1155 inherits ERC 71, and you know that metadata is have like a certain format. So any NFT marketplace or any DApp can use it efficiently. So these metadata will be the name and attributes. And again, we are gonna, as I said, we're gonna calculate the IPFS CID hash. It's really powerful because no matter what the metadata is, if the metadata like n is the same, the hash will always be the same because of the IPFS CID algorithm. That means that why we're doing this? When you make a functions request, imagine that you have like 4 nodes in a DOM. Each of these nodes will execute your JavaScript request in your JavaScript code, this JavaScript code in their own isolated serverless environment, and then we'll return the end result. And then based on that end result, based on that end result, the consensus will be reached, and it will be either response or an error will be returned to the calling smart contract. So by doing this, we're just going to calculate the IPFS hash, and we're going to return that IPFS hash. But for production ready use case, you want to have like a certain backend that will update this metadata to IPFS hash. While we're doing this off-chain and not on-chain, you saw our examples with VRF raffles or whatnot, where we calculate this metadata on-chain and store them on-chain. Well, the reason is that because if we want to have rich palette of information in metadata, that's kind of expensive to be transferred on-chain, because the call data will be big, and each 0 byte in call data costs 4 gas, each non-zero byte in call data costs 16 gas. So at some point you're gonna reach the upper limit, and because of that, we're just gonna outsource that to off-chain communication. We're gonna calculate the IPFS. We're gonna probably have like our own backend to publish the IPFS. We can also publish it from here, like that's not problem. And we're just going to store that IPFS hash as a metadata URI on-chain instead of like the whole metadata part. Okay, cool. If I just try to run this code, we should see the output and the console log here. And because I'm returning the string, we can see that this string will be returned to chain. Will there be a possibility of hash collision for IPFS hash? No, that's because we're using IPFS hash. That's a great question, but yeah, that's how IPFS work basically. And that's, I think, probably the most common place where people store their non-fungible tokens metadata. So yeah, that's it. So we are going to use this JavaScript code for the tokenized part of the token, where we're going to grab all of these metadata details. And also we are going to use this other JavaScript code for pricing information. And if you click on this URL again, you'll open now this page. And this code will be called daily. So we're going to set up Chainlink automation to call this function, to call this code, to make function requests with this code on a daily basis. So each day we want to get from the same API the list price, the original list price, and tax assessed value. So this list price is going to be always the same, like this is a constant, this is the first price of an asset. List price is if the owner in real world changed the price of the asset or whatever, like updates the Zillow API, this one will be used. And tax assessed value is actually provided on a yearly basis by a third party. So by combining these 3 assets and some other stuff, like we'll see, these are just the variables in our math formula. This is how we're going to calculate the valuation in our RWA lending exercise example. Like this is just an example. Like in reality, in production, you'll just use proof of reserve feeds from Chainlink instead of calculating like this. But again, this is a mock value. So this is like this is why this is a workaround basically. So we can make our example functional. But for RWA lending, we'll see you're just going to use proof of reserve feeds. And finally, we are going to store these two JavaScript codes in this abstract function, like contract function source. And this is the first contract that we are going to create. So now we're going to move to Remix. You can also build this in Hardhat or Foundry, but for the purpose of this exercise, I'm going to use a Remix. So if you go to remix.ethereum.org, I already have one instance open. What you're going to do is you're going to create a new workspace. So this is a basic one. So instead of that, I'm going to create a new workspace, and I'm going to actually select a blank project. So I don't care about scripts or any predefined contracts. I'm going to start with a blank project, and I'm going to name it Tokenized RWA Bootcamp 2024. And I'm going to hit OK. So here I have an empty project, and if I go back, we need to create a functions source.sol smart contract, which I'm going to do now. So function source.sol, copy the content of this code, paste here. Again, be really careful. Generally want to type this, and I'm going to save it. So we can see here that this is just a JavaScript code we saw in stored as a string variable. This is my preferred method of working with functions. We can also provide this code as a function argument when calling when making the functions request. And we can see, just be careful about quotes and double quotes. And essentially, if you scroll down a bit here, these are the rules you need to follow. It's pretty simple, but just be meaningful that when you're creating your own examples. So yeah, that's it. Now let's create our ERC1155 token. So for our tokenized asset, we chose this standard, and this is the architecture of our example. So what we're going to do is we're going to create this real estate token over here, and we are going to interact with this real estate token here. And this is the smart contract that you need to deploy and send us our address and whatnot. This smart contract actually is just inherits a bunch of other smart contracts. So there is no the actual code in it. We'll see it in a bit. But first of all, we're going to create ERC1155 core.sol smart contract, which inherits OpenZeppelin's implementation. This is the core smart contract, and here we're just gonna create develop, mint, and burn functions because we want to have those features in our token. Second, we're going to create cross-chain burn and mint ERC1155, which will use CCIP. This one inherits actually ERC1155 core and just adds on top of it a logic for cross-chain transfers using burn and mint mechanism. You can also use lock and unlock or lock, mint, and burn unlock if you want. But for the purpose of this exercise, I chose burn and mint. So that means that CCIP will burn your representation token on one chain and mint the exact same representation on other chain. And finally, we're going to create real estate price details smart contract, which will have a function call to get the price details. So that function call will be triggered by Chainlink automation. And as I said, that's like for step number 5 for issuance. We're just going to use this issuers.sol smart contract, which will have the admin privileges to mint this real estate token to Alice using the data collected from the Zillow API. And when you have one smart contract creating copies, like interacting with other smart contract like this is essentially called the factory pattern, and it's not something that came with the blockchain. This is like really old pattern and really standard pattern generally in software development. So I encourage you to Google it and check it out if you haven't, but you probably learn about it at least in university. So it's like a pretty standard stuff, nothing too fancy. I'm gonna come back multiple times to this image. So first of all, we're gonna create this core, ERC 1155 core. Again, I'm gonna create a smart contract. I'm gonna copy content from here, and then we're gonna analyze the code. So in a root directory, ERC 1155 core core.sol. Let me see if I can zoom. I can zoom this a bit. That should be fine. We'll see. If you don't see clearly enough, please let me know in the chat. Okay, cool. So first of all, we have an error here because I need to compile this smart contract with 0.8.24 version of Solidity compiler. So that's what I'm going to do now. And also, I'm gonna hit advanced configurations. So I want to enable optimization. So make sure to enable optimizer with 200 runs over here. And for EVM version, select Paris. Okay, so I'm gonna stop here. Again, optimizer with 200 runs and EVM version set to Paris, because this is gonna be a cross-chain contract. So Paris is that hard fork, like, is standard across all the other EVM chains. Some, for example, Avalanche Fuji does not have like push zero opcode or end copy, which if you compile your contract with the latest Solidity version can be present in a bytecode, so it's not deployable, etc. So again, Paris and 200 runs optimizer. Now, this is pretty standard ERC 1155 contract. Like if you want to just create an ERC 1155 smart contract using OpenZeppelin, it'll probably look similar to this one. So this is how you basically gonna start and do it with OpenZeppelin. Then you'll probably create a mint function and just mint a token ID. Over here, we have this token URIs mapping. This mapping stores for each token ID the IPFS cache of that asset. And we are doing this because calling the set URI function from OpenZeppelin is extremely costly, but you can just store it in a mapping, and then in a view function here, we're just going to override the URI function and display content from the mapping itself. If there is no URI, then the base URI will be used, the one that you provided here from a constructor. Why is URI important? If I go back here, you can see that, where is that image? Okay, that's here. You can see that when you call the URI of token ID, you get the metadata of the asset. That's why. Okay. Apart from that, there are mint and mint batch functions and burn batch functions required by your ERC 1155 standard, and this is just our implementation of it. Why our? Because we put this only issuer or itself modifier. That means that if message.sender is not this address or the issuer smart contract, this should revert. Why? Because issuer will be minting the initial token to Alice, like the initial first step using factory pattern. And after that, if you use CCIP to move this token across different chains, we'll use burn and mint token mechanism. So this contract itself will need to call the mint and burn smart contracts to implement, to accomplish sending a token like that across different chains. And that's pretty much it for ERC 1155 core. Nothing too fancy here, just like mint and burn functions with the issuer modifier. And only owner of this token can set or replace issuers. That's pretty much it. Okay. The second smart contract from this diagram is cross-chain burn and mint ERC 1155. So let's open that one. So first of all, let's create cross-chain burn and mint ERC 1155. And if you attended our CCIP bootcamp, this should be pretty straightforward and easy for you, but I'm going to repeat it anyways. So cross-chain burn and mint ERC1155 smart contract. That one, as I said, inherits our ERC1155 core. You can see I'm importing ERC1155 core from the root of my directory, not from external service. And if I try to compile this smart contract, we'll see that it will fail because we cannot find the withdraw smart contract from the util folder. And I'm going to talk about it in a minute. But for now, let's analyze this smart contract. So this smart contract inherits ERC1155 core, inherits IIN any to EVM message receiver from the CCIP contracts, and a reentry cigar from OpenZapline and withdraw from utilities. We're going to talk about it in a minute. These are the two important ones. So ERC1155 core, that means that it will have all of these functions we have with that smart contract: mint, mint batch, burn, burn batch. And any to EVM message receiver means that if we implement that interface, that means that we can receive CCIP messages by implementing the CCIP receive function. Okay, cool. So what we're gonna do? So if you go to cross-chain transfer function, cross-chain transfer from function, essentially it's the same as transfer from function of ERC1155, but you're also gonna provide destination chain selector and pay fees in enum. So pay fees, you can pay for CCIP fees in native or link, 0 or 1. Native message at value, link address of link token. I'm going to use link. And here we are going to get the metadata of the token using the URI function. You see how I call it like this, because I essentially, this contract, because of the inheritance, can call all of these functions, and only issuer or itself. So message sender is address this. You see. So store that in a memory variable, then call the burn function. So essentially, at this step, we're gonna burn the token. So there is no token. That token does not exist, like fungible part does not exist on this chain. We're gonna form a CCIP message. So essentially, receiver is the cross-chain NFT address, like the same smart contract got on other chain. That will handle minting. Then data we're sending is essentially this data plus token URI. We're not sending any tokens. For extra arguments, we're going to grab that from our mapping, which basically is here enable chain, the disable chain by the only owner. This step is done only in a setup, so don't worry about it. And for fees, we're going to just see using this enum, whether it's like link or native. And the rest is just logic that will handle sending the cross-chain message using CCIP. Now, on the other side, we are going to implement CCIP receiver. And inside CCIP receive function, first of all, there is like a bunch of modifiers to only receive message from specific chains, from specific senders, and whatnot. So all of that, again, done in a setup function. If you follow our CCIP bootcamp, this is all familiar with you. If not, I'm going to explain that as the last step of exercise number 1. But essentially, we are going to grab source chain selector from a message itself, EVM to any message itself, and then from the same message, we are going to, from data field, the same message we're going to grab from to ID, amount, data, and token URI details, and we're going to pass the details to the mint function, and the same fungible part of fungible tokens will be minted on another chain representing exactly the same asset, because we have this token URI, token ID, and all that stuff that uniquely represents our mock tokenized real estate. So that's for that part. So this function just has this cross-chain transfer from and CCIP receive function, which is the way to receive CCIP messages. And besides these two functions, there is also this enable and disable chain, meaning that as an owner, when you want to deploy or connect your cross-chain asset with the same asset on another chain, you need to provide the chain selector of that chain, the address of that asset on that chain, and CCIP extra arguments if needed. Like the gas limit for sending the CCIP messages, and that's pretty much it. Those steps are like done by the owner, so you don't really need to worry about those. But this is how you can connect. So this is the way to let your smart contract know the existence of the same smart contract on different chain, so they can communicate between themselves. So basically you have cross-chain transfer from and CCIP receive function here, or just cross-chain transfer from. Okay, cool. Let's figure this error. So we have a compilation error because there is no withdrawal function. So inside the root, I'm going to create a new folder called utils, so for utilities. And inside utils folder, I'm going to create withdraw.swl smart contract. This smart contract is extremely simple. I'll find it. So create withdraw smart contract in utils. I'm going to copy it, paste it here. And you can see that this is extremely straightforward smart contract. It withdraws native assets or tokens from this smart contract, because we'll need to fund this smart contract with either link or native coins if you don't want to use message.value from the user in your implementation. So you need to have a way to withdraw tokens, any stuck tokens or coins from your smart contract. So don't forget this smart contract. That's the only thing that it does. It's extremely straightforward. That's why it is in the utils folder. Okay, cool. Now let's create the real estate price details. So technically, for the tokenization part, you don't need this smart contract. I implemented this smart contract because I'll need it for my exercise number 2, where I'm using RWA lending.sl, because my lending protocol cannot use proof reserve feed of mock unknown real estate. I needed to create this smart contract, helper smart contract, to get some kind of price details and calculate them on chain. But in production, you're probably not gonna have anything like this. You're just gonna use Chainlink proof of reserve feeds. That's it. But still, I'm gonna copy this code. This is another smart contract that just real estate price detail that just utilize Chainlink functions. So real estate price details.sl. So I'm just gonna add that one as my functions consumer as well. I'm gonna hit a save, command S to save this smart contract. And we can see here, again, it's like a function client. Again, in here, it's function source. So function source is basically this smart contract. So you can call the get prices code, and real estate price details over here. It does nothing but when you call the update price details function, which can be only called by automation forwarder or the owner, because we're going to automate this function to be called by automation, it creates a new JavaScript, a new functions request for inline JavaScript with the code we just saw. This one, with prices, and it'll be called daily, create a send request, and inside the fulfill request, extremely simple, decode this request and store it in a mapping as a latest struct. You can see here that this is actually a struct, right? This is Solidity struct. And extremely useful thing is that when you work with structs, when you're working with structs in functions, I'm gonna, first of all, here I'm returning strings. So with functions, you can encode string, you can encode unit 256, you can encode whatever, like just encode as a Solidity data type and return. But if you want to handle complicated structs in Solidity, it's actually really easy, because what you can do is you can just encode them as a byte. So this is essentially as doing the same thing as doing ABI encode on chain. Here I'm using ethers because I'm in JavaScript, and I'm just returning bytes, raw bytes, because essentially functions just send raw bytes. And then once I receive those raw bytes, because here it's encoded with 4 unit 256 values, I'm just gonna, in my smart contract, call ABI decode. It's over here. So ABI decode, the reverse function of ABI encode, and I can have all the fields of my struct. So token ID for a mapping, and then these 3 prices to calculate in a struct. I know that doesn't like, I mentioned this because like a lot of you ask me throughout the year how to handle structs in functions, and it's really, really simple. It's really that easy. Also, if you're working with functions in a Hardhat or Foundry, I'm gonna, in the repo of this exercise, and I'm gonna also share it and tweeted about it a bunch of times. There is like a I think 5-line or 6-line function for simulating requests using the functions npm toolkit. I'm going to show it to you, but that's the same way, like to simulate basically this behavior in your project if you don't want to use Playground for any reason. Okay, cool. And I think that's it. Yeah, finally is to create real estate token. And this is our smart contract. If we go back to the architecture page, so this is the smart contract we're going to interact with. And by inheriting all of these smart contracts, we'll have all of the functionalities from each one of them, but we're going to just interact with our real estate token as well smart contract. This is the address of our tokenized asset, actually. Like it's kind of like Lego bricks, as I pointed out here. So if you go to create real estate token, you can see that that's the whole code of it. And I just added this this art a bit. ASCII art real estate token.sol, but essentially it just inherits, if I zoom out a bit, it just inherits these 3 contracts. So this one inherits ERC 1155 course, this one, and real estate right details. And there is a constructor to initialize it, and that's it. that's pretty much it. So I'm going to compile this, and yeah, our job is now done. Now we're going to deploy the smart contract to Avalanche Fuji, and even though there is absolutely 0 functions implemented here in Solidity, we will see in a bit, once I deploy this smart contract, that we will have all of the functions I previously mentioned. And yeah, really cool art. Thank you for that. But I used the generator, the free generator online. I'll find the URL probably. So yeah, that's it. Okay, cool. So again, we need to make sure that optimizer is turned on, 200 runs, and Paris EVM version is set. 0.8.24 is the version of Solidity compiler. And here I'm gonna select injected provider MetaMask. So it connected to 43113. So if I do 43113 chain ID, we can see that that's the details for Avalanche Fuji. So make sure to validate that. That means that my MetaMask wallet is connected to Avalanche Fuji. Okay, cool. I'm getting a warning that my real estate token.so smart contract size is too big. So I'm going to repeat for the 3rd time. When you compile your smart contract, hit enable optimization with 200 runs to turn the optimizer on, and also set EVM version to Paris. And it won't give you that error anymore. Okay, going back. Whoops, sorry about that. Let's expand this a bit shortly. So going back here, I'm on Avalanche Fuji, injected provider, and I need to provide, as we said here, URI, the base URI for ERC 1155, address of CCP router, address of link token, current chain selector. So that's the chain selector, CCP chain selector of Avalanche Fuji, and the address of functions router smart contract. All of these can be found here, but please always double check them and validate against the official docs, which I'm going to do now. So I'm going to go to docs.chain.link, and we're going to do this nice and easy. So for the URI, I'm just going to have the empty URI because I don't have like a base one, so just empty. But when we tokenize the asset, we'll have that IPFS hash. Second, CCP router address. So I'm on Avalanche Fuji, so I'm going to go to CCIP. Supported networks testnets. I'm going to go find Avalanche Fuji over here. Router address is over here. So I'm going to grab this address, and you can see it's F6 is the same thing, and paste it here. Then the address of a link token. So again, link address, copy from here, link, and paste here. Current chain selector, that's CCP chain selector of Avalanche Fuji. So it's not chain ID. It's not 43113. It's this UN64 value. Again, if you followed our CCP bootcamp, there was actually a question in an easy section what chain selector is. And if you hover over here, it's CCP blockchain identifier. So I'm gonna grab that value and paste it here. Again, 14 is the same thing. And finally, functions router smart contract. So there's two ways to get the functions. So first one is to go to functions, is to go to supported networks tab, is to go to Avalanche Fuji testnet to find it here and grab it from here. Remix and paste it here. Or if you go to functions.chain.link, over here, the home page, I'm gonna just disconnect. Let's see if I can. Yeah, I'm gonna disconnect my wallet just to show you the process. Disconnect all accounts. I think no. 1 second. Sorry. How to disconnect this thing? Oh, it's okay. Sorry. Well, you cannot see my MetaMask. Okay. Let's refresh. Okay, cool. So if I click connect wallet, I'll need to accept terms of service. I'm gonna connect with MetaMask. I'm gonna hit next, confirm all of that stuff. I'm connecting, and again, I can see the dashboard. And over here, there is an address of a link token and a functions router. So this one is exactly the same as the one we got from the docs. So this is how we can verify it. And I'm gonna paste it here one more time. Finally, I'm gonna hit transact to deploy the smart contract, and I'm going to hit confirm, and I'm going to wait for a transaction to be included in the next block. Here are. So if I go over here and expand it, you can see there are like a bunch of functions over here, even though the smart contract itself here appears to be empty, but it's not. So yeah, bunch of functionalities. The one we care about at the moment is set issuer. So over here, there is a set issuer. That means that we need to provide the address of issuer smart contract that will be able to mint our NFTs. And why is that? Because if we go to ERC 1155 core, we can see that there is a set issuer function over here. And because the mint function can be called by only issuer or itself, so issuer is the only external actor that we call the mint function. That's why we need to set it first, because this syntax over here means that issuer is currently address 0. So no, it's not assigned because there is no constructor or whatever. So we need to call this function with the address of issuer. But for us to be able to call this function by the address of issuer, we first need to deploy the issuer smart contract. So to do that, I'm going to go back to File Explorer. I'm going to hit create new file and type issuer.sol. Hit enter. And again, I'm going to just copy this code and I'm going to explain it to you. All right. So again, it's not too big. It's literally 72 lines of code with all of the comments and extra stuff. I'm going to just compile it. So first of all, it's again importing Chainlink functions, and there is a struct which is a fractionalized NFT. So you have like address of a receiver and the amount it's receiving. That's it. So here is the main function. It's the issue function. So this issue function can be called only by the owner of this smart contract. And essentially here we are providing the address of Alice, and we are providing the amount of fungible tokens we want to mint for this non-fungible asset. So again, amount is this thing. So if I go back to the Gitbook, we can see that we have one real estate, but 20 of these fungible assets. 20, if I provide 20 as amount over there, that means that 20 of these tokens will be minted. And that's what I want, okay? And 20 is like 100% ownership, fractionalized ownership of this real asset. And then if I send or sell or whatever, 5 of these tokens, that means that I sold or loaned or whatever, 25% of this token, okay? That's why we're using ERC 1155. Over there is the subscription ID of Chainlink functions, because we need to create a function request to get the metadata to populate it. Guest limit for Chainlink functions and DON ID for Chainlink functions. What is DON ID? Over here, if I go to supported networks, this is the DON ID. Is the string used for functions toolkit npm package, while the byte32 hex is used for on-chain DON calls. So we're not going to use fun avalanche Fuji or whatever. We're going to use this byte32 value for on-chain stuff. This is the ID of the DON, of decentralized Oracle network, that will execute our requests. All nodes in this DON will, so this is how we can ping, hey, this DON, please execute all of this and reach a consensus. Or if I go to functions dashboard, here I can just grab it from here, the DON ID. This function will then just create a new request. And once Chainlink functions call the fulfill request function, we will see that, first of all, response will be string. If I go back here, so we are returning string, you see, string. So that's what we're expecting. So this string will be returned to our smart contract, but in forms of bytes. So we're just going to cast it to string, and we are going to just call the min function of real estate token with all these details plus the token URI. And that's it. Also, to prevent race conditions, there is this last request ID and issues in progress mapping. This is a storage variable. This is issues progress mapping. That means that if one minting of one ERC 1155 token is in progress, there cannot be another minting. And if there is an error or whatever happened, well, for example, I experienced on testnets that when I imported this library for IPFS, the first time it will just revert, and then if I repeat the process, it will work. We'll see about that. But there's always this cancel pending request. This is just for testnet stuff, that you can cancel the pending request if there is an error on the function side and just repeat the process. So I think I put that here as a troubleshooting for homework. If you experience any issues, with deployer, you can see here that you can always call the cancel pending request and try again. Okay, let's put this thing in action. So after we deploy the issuer, we want to call the set issuer function. That's why we're doing all this stuff. So I'm going to deploy the issuer smart contract, and I'm going to call the set issuer function on the real estate token contract to say basically to it, hey, this is the issuer contract that will issue you using the factory pattern. Simple as that. Okay, so if I go back to Remix and once again compile this issuer smart contract, it's compiling. See, it's in progress because of the optimizer. We're gonna wait for that. Here it is. It's done. I cannot drink water. Okay, cool. If we go back to the constructor, we can see that we need to provide the address of a real estate token and the address of function router. So address of real estate token is this one, the contract we just deployed. So I'm going to just scroll down here, copy the address from here, and paste it here. And for functions router address, again, either documentation or here from the functions dashboard. So I'm going to paste that, and we can see 89. Okay, all good. I'm going to hit transact and deploy the issuer smart contract. You are now cannot see my MetaMask, but it pops up. I'm going to hit confirm, and I'm going to wait for this transaction, which is pending, because you can see here, to complete. Okay, cool. Confirmed. I can see my issuer smart contract over here, and it's a simple smart contract. We'll just be able to call the issue function and transfer ownership if needed, but we won't do that. Ownership of this smart contract. So what I'm going to do, I'm going to copy this address and provide it as a function argument of set issuer over here. So set issuer of the real estate token address, paste, make sure that this is the correct address, looks like. So I'm going to hit transact, and I'm going to hit confirm. All right, we're all set for the issuing part. So to recap what we have done so far. Where is that thing? Here it is. So we developed these smart contracts and deployed real estate token, which represent our asset. And then we deployed this issuer smart contract, which will issue assets, our tokenized assets. And this is because step number 5, the issuing part of real world assets, is not covered by this bootcamp. So what essentially we're going to do, we're going to mint the tokenized version of a mock real estate to Alice. Simple as that. And also for us to be able to do that, we on this smart contract real estate token called the set issuer function to basically signal to this smart contract, hey, if you only receive a call to a mint function from this address, execute it, otherwise revert. And now what we're going to do is let's issue the tokenized asset. To do that, again, we need to call the functions to get an NFT metadata. And for us to be able to do that, we first need to create a new function subscription. So what I'm going to do now is, once we deployed issuer, that's where we left, and call the set issuer function, that's what we did, we need to create Chainlink function subscription and fund it. And to do that, you can go to functions.chain.link, as we already did. It's right over here. Let's put it over here and create a new subscription following the instructions here or from the official Chainlink docs website, or just watch me doing it. It's really straightforward. So I'm going to create new subscription. I'm going to provide my email address. Subscription name will be Tokenized RWA Bootcamp 2024. And I'm going to hit create subscription. My MetaMask will pop up at some point. You cannot see that, but you see that one thing. I still haven't figured out how to show my MetaMasks during live streams. Sorry for that. But I'm going to hit confirm. And I'm just going to follow the process here. It's really simple. Like this interactive pop-up diagram will just follow you. You just now create one transaction. Okay, it's confirmed. I'll need to sign a message now, so you cannot see, but this is literally a signature. So the message is, welcome to Chainlink Functions. We require a signature in order to ensure you're the owner of subscription. And I'm just going to hit confirm. And once I sign this message, I will be prompted with the next step. So it's literally just installment, like or creation of Chainlink Functions. It's a subscription. It's really simple and easy. See, okay, subscription is created. Great. What I'm going to do now is I'm going to fund it. So I'm going to add funds. I think I mentioned 10 link. Is that right? Yeah, we're going to provide 10 link. That should be more than enough for this exercise. So I'm going to just do 10 link, and I'm going to hit add funds. And I'm just going to approval adding of 10 link to my subscription. So, you know, like for all function calls, I'm going to just use those 10 links. So I can always cancel upkeep and get links back, or top up subscription, or, you know, there you'll soon be able to see the dashboard if you haven't seen Chainlink Functions already, Chainlink Functions dashboard already, but I assume you have. Okay, we're gonna just wait for this transaction to complete. And final step, yeah, I'll need to add consumer. In my case, I'll add 2 consumers. So the first consumer is our issuer smart contract. So I'm gonna go grab here and add issuer, because this is the one that will, let's see, FA. Okay, this sounds about right. Looks about right. So I'm gonna add this consumer, and this is gonna be my last step for creating a subscription. But I'm also gonna add real estate token as another consumer. So I'll have 2 consumers, because if you remember for exercise number 2, I need to call that get price detail function periodically each day. So I'm gonna just do it while I'm here. That's pretty much it. Okay, we're gonna wait just a bit for confirmation to arrive, and that's it. So if I click hit view subscription, I'll be able to see my dashboard. So we can see here that I'm the admin. This is the subscription ID. So this is really important. We're gonna pass this subscription ID back and forth for each subscription. So that means that functions know which subscription to trigger for which consumer contracts and from where to subtract this link. These are the actions you can do. You can fund subscription, cancel subscription, and whatnot. And here I can see my consumer and some history. So what I'm going to do is I'm going to hit add consumer button one more time. And for a second consumer, I'm going to add real estate token address. Token smart contract address. Sorry. And hit add consumer one more time. And if you follow Gitbook, it basically says add after you fund subscription, add these addresses as a consumers and remember your subscription ID. That's it. So we're just gonna wait for, transaction just got confirmed. I see a MetaMask pop-up, so this should be done pretty soon. We're gonna wait. This is just waiting for a transaction to be completed and not end up on a fork because of chain reorg and whatnot. Yeah, here it is. Transaction added. I can view a transaction, but I'm going to just close. So I can see two consumers. You see how the second consumer appeared over here. So what I'm going to do now is I'm finally going to call the issue function. So that's the part number 5 tokenization paradigm, where as I said, we're just going to mint this mock real estate token to Alice address, because this is again out of the scope for this bootcamp. So what I'm going to go do is I'm gonna collapse all this. I'm gonna call the issue function. So I'm gonna paste my address. So I'm gonna issue this to myself basically. So I'm gonna grab my wallet address from here. Again, as amount, I'm putting 20. So that means 20 fungible assets to represent a fractions of that tokenized real asset, like 100% of it. You can put arbitrary number here, of course. Subscription ID. Subscription ID is the subscription of my Chainlink functions. Is the ID of my Chainlink function subscription, which I'm going to grab from here. So 12769. Repeat 769. Don't use my subscription ID because your contracts are not consumers. So it will just revert a bunch of the time, and you cannot just use my balance. So you need to create your own function subscription. So I'm gonna grab mine. For gas limit, if you go back to Gitbook, I put 300,000 as like a maximum. This is the maximum, this is the cap, and this is non-refundable. So definitely for production use cases similar to CCIP, you want to measure this. It worked with 100K with 100,000 as well, but essentially for production use case, either in Foundry or Hardhat, you want to estimate these gas limits accurately, so you're saving gas, of course. But here, for the purpose of this exercise, just to make things run, we're going to use the maximum thing. And finally, non-ID. So fun avalanche Fuji 1. Again, you can grab it from here. You can grab it from docs. I'm going to grab it actually from Explorer over here. So I'm going to go to dashboard, copy this thing to clipboard, is byte32 value, and paste it over here. And I'm going to hit transact. And now my MetaMask pops up. I'm going to hit confirm, and I'm going to wait for this transaction to complete. Now, if I go back to my subscription, you can see here I have this tokenized RWA subscription over here. We can see a pending request. So over here in real time, I can track the status of my request. As I said earlier, there is a chance that it will revert for the first time because of import of that IPFS function, IPFS library, but doesn't matter. Like, this is the issuance part is nothing critical. We can just cancel the pending request and repeat the process. But right now, let's see if that's going to happen. Yeah, it happens. So again, we have errors, like either both in computation and callback. So what I'm going to do, go back, I'm going to hit the cancel pending request function. So, and I'm going to wait for that transaction to complete, and I'm going to repeat the issue one more time. And this should work. Okay. if I go back here and refresh, I should see another pending request, and this one should succeed. Okay. While we're waiting, I'll try to answer some questions in a chat. Okay. Oh, there's a lot of them. I'll start one by one then. Okay, this is all about fees and config details. So just read the Gitbook carefully. And speaking of fees, you can always, speaking of fees, actually, I'm going to share you something. So if you go to GitHub and type RWA-primer, this is where you can find the source code for this thing. So essentially, like I deploy this in Foundry. So essentially, you can just instead of testing directly on testnets, you can just test everything and build everything locally in your development environment of choice, instead of like dealing with gas tokens over and over again, of course. And yeah, Chainlink Local will soon support all chain services, so it's even easier. Finally, after we've done this step, we're going to create a Chainlink automation subscription to call the update update price detail functions. So this again is needed only for tomorrow for the second exercise, but I'm gonna still do it now. So first of all, let's see what's going on with this computation. No, error again. Syntax error. Okay, we're gonna try one more time, and if that doesn't work, we're just gonna use the contracts from yesterday. But yeah, this should work. One more time. Maybe I did it too fast. It happens. Is there no way to create this subscription using a contract? Yes, there is. Yes, there is. The only requirement is to go to subscriptions page over here for the first time to sign that message when you connect your wallet. Okay, we have greens. So is there a way? Yes, there is. So how to do that? Go to the dashboard. When you connect your wallet, you will need to sign that message, and that's it. And after that, if you go to docs.chain.link, and if you go to Chainlink functions, there is a guide to where is that guide? To create programmatically. So there'll be it's here somewhere. I'll try to find it. But yeah, there is like a code for that. I don't see it right now. I'll just paste the link afterwards, but in a doc. And basically, it's a programmatic creation of a function. But until I find that, we can. I'll send you that while you're doing the exercise. We can see here that our computation callback status is green. It's all good. Sorry about this. It's just the caching thing in a down for that IPFS library. I'll find a better one, I promise. But that means that we finally minted an ERC1155 token to Alice. So that means that if I go here at call total supply, it's 20, and total supply of token ID 0 is 20. But if I have another token, it'll be maybe 40, whatever. And now what I want to do is to get the price details of token ID 0. So if I go to this smart contract to get price details of token ID 0s, at the moment it will be 0, right? Because we haven't called the functions yet. So it'll be 0 as I see. it's just returning details from this mapping. This mapping is updated when we call the update price details. So it can be called by automation forwarder or the owner. So that's why I also added this smart contract as a consumer to my functions subscription, because if I call where is that function? Update price details over here as an owner, this should also trigger the functions, and we want to test that. And also, after I do that, I'm gonna just automate this to be called by Chainlink automation for tomorrow. So again, this is only for tomorrow's exercise. So I want price details for token ID 0. Subscription ID is my function's subscription ID. So I'm gonna just grab it from here and paste it here. For gas limit, I'm also gonna use the same value, like 300,000. Yeah, there it is. And for the Don ID,
I hope you can still hear me. If you cannot hear me, please let me in the chat. It should be. But I'm going to just call the update price details manually so I can show you what we are expecting, but then I'm going to automate this function to be called every single day. Okay, cool. Thanks for the voice has back message. So again, this is just for debugging purposes. What I'm going to do now is I'm going to call the functions. I'm going to make functions request to call this piece of code to get price details. So a different one. And this piece of code will be called daily once we automate it. Just for the demo purposes, I'm calling it now from the owner address. And we can see that this is also pending. So we're waiting for this to be populated. What we want essentially is when we call this get price details to not return 000, to return actual values, because this thing mocks or simulates the behavior of Chainlink proof of zero feeds. And this function will be called or consumed by RWA lending smart contract tomorrow. But because we, again, as I said multiple times, there is no proof of zero feed for a mock Zillow API real estate, we need to somehow mock it like this. And that's the only reason why we're doing. Okay, let's see the status of our functions request. All green, everything's great there. So once I call this, I should be able to see different prices, and it's updated. So you can see 70. So you can see prices. Let's put them here. So that's what's the name of the original price? List price, original list price, and text as value. So this will be list price is in US dollars, literally US dollars. It's like this. Original list price is this value, and tax assessed value is this price. So for this asset, tomorrow we're gonna convert all of these US dollars values to USDC plus some math plus whatever, plus some algorithm to calculate the valuation of our real world assets for lending and borrowing purposes on that mock platform. But yeah, that's why we received this values. And now, like, I call that manually from my owner address just for demo purposes, but we want this to automate. I don't want to call this function every single day. We want this function to be called daily. And to do that, we are going to create a time-based upkeep subscription using Chainlink automation. So I'm going to go to this link. I'm going to go to automation.chain.link. This is the official dashboard. I'm going to disconnect my wallet once again to show you the whole process. I'm going to disconnect this account. Okay, so first of all, I'm clicking connect my wallet. I'm accepting terms of service and connecting with MetaMask. And that's the only thing that you need to do for functions to create them from that wallet address programmatically. That's the only thing. Plus that code I'm going to show you. And I'm connected, and now I'm going to hit register new upkeep. I'm going to select time-based trigger. So there is time-based, custom logic, and log trigger. Custom logic is the most powerful one you have, but for that one, you need to have automation-compatible function smart contract, which essentially inherits an interface, automation-compatible interface with two functions: check upkeep and perform upkeep. Check upkeep should return true, false, and then if true is returned, the perform upkeep will be called. If not, nothing will happen. Log trigger and that happens on a fixed time interval. Each block, each 5 blocks, depends on the chain. For log trigger, you're subscribing to specific events from a specific smart contract. Once those events get emitted, the perform upkeep function gets called. So it's kind of like publish receive pattern, something like this. And time-based, which we're going to use, is just going to call the function you provide on a fixed time interval. That's it. It doesn't need to be automatic compatible contract, anything. It's extremely simple. So I'm going to hit time-based, hit next. I need to provide the address of a target contract, and we're going to provide the address of real estate token smart contract, because here we want update price detail function to be called out each day. So this is our target. I'm going to hit next. Now, we haven't verified our smart contract on a block explorer yet, and we won't because of the lack of time. So I need to, because it cannot fetch ABI automatically through the public explorer, I'll provide ABI myself. And ABI stands for Application Binary Interface. It's a product of a Solidity compiler. When you put your smart contract through the Solidity compiler, it will generate ABI, which is a JSON, and the actual contract bytecode. So I'm going to grab the JSON. How can I do that in Remix? Well, if I go to compiler, if I compile this smart contract, so this is the smart contract I want to compile, real estate token, there is this ABI thing over here. So I'm just gonna, once compilation is done, I'm just gonna click it, and that means I copy it. And if I put here, you can see it's literally a JSON. Well, you can't see that, but it's a JSON. I mean, this is a medium to advanced bootcamp, so you know what ABI is while I'm babbling about it. But essentially, I'm gonna click next, and now target function, we want to call update price details. So this function, we want to call it. So again, update price details. And we need to provide some arguments to it, right? Okay, so token ID is, again, 0. This is the token ID we want to query. Next is subscription ID, function subscription ID. So that's this one. I'm gonna copy this value. Gas limit, same as here, 300,000, copy, paste, and Don ID will be probably the same value as this, but I'm gonna copy it anywhere from here to here and hit next. Now, this is the most important part. We need to provide a cron expression for our time schedule. Like, cron is extremely powerful thing, simple but yet powerful. I really like it, and this is the basic explanation of what cron expression is and how it works. But the great thing about Chainlink automation app is that you have these helpers over here. So every hour, like this, first of every month, like this. So you don't need to type your cron expressions manually. However, if you go to Gitbook, you can see that 00 and then 3 stars or asterisks is the cron expression for each day. So we can see here, this means that we want to call this function each day or every 24 hours. And it's great because we can always validate this on the UI against next 5 scheduled dates. And we can see October 1st, October 2nd, 3rd at midnight UTC. So that means that at midnight UTC, our function will be called again. So for tomorrow exercise, I will have these price details mocked. ready instead of zeros, right? So that's it, and each single day it will be called. So I'm going to hit next. And finally, I'm going to add a name. So the name is Tokenized RWA Bootcamp 2024. For gas limit, I think I put 300, yes. So I'm going to lower this down a bit. Again, you want to test this and measure this. And for link, 5 link is, 5 link is enough. So I'm going to just put 5. And this is all optional. So I'm going to skip this and I'm going to hit register upkeep and just follow the process. So again, MetaMask pop-up that you cannot see. I apologize for that. Hit confirm. And wait for confirmations. Okay, it's confirmed. So now I have a new MetaMask pop-up that you cannot see. So I'm going to hit confirm to that one as well. I'm going to wait for this process to complete. And finally, I'll need to sign a message. So I have another message. Welcome to Chainlink Automation. We require signature in order to assure you are the owner of the upkeep. Yes, I am. I'm going to hit confirm and cryptographically sign this message. So I'm going to wait for that to proceed. And voila, we successfully created time-based upkeep. So if I click view upkeep, I should be able to see a dashboard, my admin dashboard, with details about status is active. This is the registry address, the balance, how much is spent, last date run, not, and all the other details, history and whatnot. The important address I'm looking here is this forwarder address. So throughout this smart contract, the Chainlink automation Dawn will actually trigger my update price details function. And if you don't want your smart contract to be spammed, or if you want your smart contract to be called only from a certain accounts, as is the case with our smart contract, because if you go here, only automation forwarder or owner can call, and this is the modifier only automation forwarder or owner. That means that we need to call the set automation forwarder function and provide the automation forwarder address, which is this one. So I'm gonna copy this address to clipboard over here, go back to real estate token.sl, call the set automation forwarder. Let's see, set automation forwarder over here, paste this address, hit transact, and this is the last transaction that I'm gonna execute for today for this exercise. Once this transaction is completed and included in the next block, which just happened, that means that we successfully set up this flow with time-based upkeeps, and we can now relax, and because it'll just call our function each day at midnight UTC, I think. So that'll be pretty much it. The last step over here is how you can enable cross-chain transfers. And in the interest of time, I won't do that because it'll take us like another 10 minutes. But essentially, you're just going to deploy your real estate token smart contract to a new blockchain, let's say Polygon Amoi. And let's imagine actually that we deployed real estate token to Polygon Amoi. Let's say I just deployed, it works great. Now, on both Fuji and Amoi, I'm going to call the enable chain function and provide the chain selector, the address of real estate tokens, and CCP actual arguments for Amoi and all of the other chains. And again, I'm going to go back to Amoi and call the enable chain there and provide details about my smart contract real estate token as well on Fuji, chain selector of Fuji, and CCP extra arguments. By doing that, I'm going to link them, and after that, we'll just gonna be able to enable cross-chain transfers. So essentially, imagine that I just deployed real estate token as well to Amoi, and then here I switch chains in MetaMask, and I found this enable chain. So for chain selector, there'll be, let's see, this is functions. So let's go to CCIP, testnet. So we are looking for chain selection of Polygon Amoy, right? So I hope I'm pronouncing that right. It's over here. So I'm gonna provide this chain selector, right? So put it over here. Here is gonna be the address of my real estate token on Amoy. So I'm just gonna grab that from here. And CCP extra arguments, like you can just encode it to be empty or 200,000 or whatever, depends on your use case. If you remember CCP Bootcamp, we had that nice helper function contract over there. Paste that, hit transact, and you will be able to send and receive CCP messages from and to Polygon Amoy from this smart contract and to this smart contract on Polygon Amoy, basically enabling burn and mint mechanism using CCIP. That'll be it. A lot of stuff. Just go easy. We're just gonna give you some time to perform this exercise. Nice and easy, steady. And once you do that, as a homework, you can submit the address of real estate token and issuer with this form. Actually, save this form for tomorrow, because once you deploy these two contracts as well and perform transactions, so not just deploy contracts, but do all these steps so I can see transactions, submit them via this form. We have a deadline for October 4th, and we're gonna review those submissions. And if you score more than 80% of more, so all these steps, you're gonna earn the on-chain certificate of completion of this Tokenized RWA bootcamp. Okay, so that'll be it. Now I'm gonna play some music. I'm gonna stick around to answer questions and just try to do this exercise number one by yourself. If you have any issues, I'm here to help, and so is Richard. So yeah, let's first find some music and start with the exercise part. Let's see where the music is. Do you want some lo-fi maybe? We'll start with lo-fi. If music doesn't work, we can always change. How does that sound? Okay, I lowered the music down a bit, but if it's too loud or whatever, I can adjust it. If you don't like the music, we can change it. And yeah, now I'll try to answer questions. Okay, cool. I'm almost done with all the stuff. Do we need to verify the contracts as well for the homework? If you have time, you can, but it's not hard necessary. However you like. Former music was better. Okay, I'll try to find former. If I remember, I think was this. Is this one good? Okay, cool. Let's see. Speaking of time, we have, I think, a little over 1 hour. So plenty enough time for you guys to do the exercise, to ask questions. I'll be around during the whole session, so yeah. Okay, cool. What does it mean if the computation status is green, but the callback failed? Is this okay? No. So computation is like, first you create a request, and then computation is part of like where each node in the DOM executes your JavaScript code, reach a consensus and whatnot. We want this to succeed. In my case, first it fails because of that IPFS packet import, but eventually succeeded. The second one is callback is delivering this message to your smart contract. So if calling the fulfill subscription failed, it will fail as well. So if you want, I can debug this right now with you on stage, but we want both greens in order to happen, because that means that like result has been computed, but we haven't delivered it properly. Okay, what needs to be filled for the Dawn ID in automation? For the Dawn ID in automation, we want the Dawn ID, this one of Chainlink functions. So the same one, because it will periodically call this function. So basically triggering the functions request. Also, if you go over here, we see that that's basically a function argument of update price details. So yeah, this is the Dawn ID. This one we want to provide. This one from Chainlink functions from here, this value. Okay, call. What else? This is an excellent question. Can we deploy it to another testnet, I think? And if yes, is there any different configuration of arguments? Yes and yes. So basically, you want to deploy this to all services where Chainlink, to all blockchains where Chainlink is. And if I think, yes, if you click, you can see here, quick links in the docs over here, right over here. You can see that where all of the on which blockchains all of the services are available. So we are using CCIP, we are using functions, and we are using automation. Tomorrow we will use data feeds as well. So if you see all green checks, that's where you can deploy your smart contracts. So that'll be Arbitrum, Avalanche, Base, Ethereum Sepolia, where else? Optimism Sepolia, Polygon MOE, all of these blockchains works. So you can just deploy to those blockchains, to those testnets. And then configuration is different, right? So for example, if you want to deploy to Polygon MOE, so CCIP router address will be this one, chain selector will be this one, link address will be this one, instead of for Fuji, this, which are different values, you can compare them. For functions for functions router, again, go to supported networks and find it, Polygon MOE testnet. So functions router, this one, Dawn ID, this one. So it's all going to be different, but you can, and you should always grab them from the official Chainlink docs. And it can actually be a nice exercise to maybe deploy to some other blockchain, not just because of the faucets and whatnot, to see whether it's going to work, because essentially, like you want to just switch config details, the rest of the code base will be the same. And it's a good test for you whether you understand all the lines in the code base, which you definitely should, and will be able to after this bootcamp. So I'm going to hide this comment. You are welcome. Also, as I said, we'll have 1 hour for the exercise part, because unfortunately, Limpy team won't join us. So, whoops, so this during the last minute cancellation and conflict, we're gonna skip this talk. So that means more exercise time for us, and hopefully we will hear from Andre some other time. So yeah, more time for exercise. Take your time, slowly ask questions, and yeah, I'll try to answer them. Hey Andre, are you coming to the Hacker House? Unfortunately, no, I won't be. There will be some other colleagues of mine and developer relations engineers, but for me, it's like I have other commitments and other priorities to finish, and yeah, some other folks from APAC region will join you in the Hacker House. I'll support virtually. So yeah, unfortunately, we will not meet each other in person. But yeah, you can always ping me on Twitter. Very advanced tools. Many thanks. You're welcome, Tayo Web. I hope you find this useful. Okay, cool. Let's see. More questions. Could you show us again how to put withdrawal sol under utils withdrawal? Yeah, that's really simple. So if you go to File Explorer, basically this is a root folder, and I have all of these contracts in root. Then in the utils folder, there is withdraw. So what you will do is you will create utils. I'll just do utils1 because I have already that folder. So create that folder and then create new file withdraw.sl inside that folder, and you're done. I'm just going to delete it now. Okay, that's it. Great session. Thank you. Okay, well, let's see if there's any technical questions for the session. Oh, this is a nice one. Can we tokenize social media account of user on decentralized social media, which will work on crowdchain platform? Yes. The cool thing about decentralized social medias, I don't know, like Lens or other protocols, is that you own the account. So technically, you already have the NFT represent the ownership of that social media account. What you can do is, because it's on-chain, it's really easy. You can just utilize it and add extra functionality on top of it, whatever you want, in an additional smart contract, and add CCIP stuff, like as I did, like with this cross-chain burn and mint ERC 1155 smart contract, and that's it. You had it. So with on-chain social media stuff, it's decentralized social media. It's really easy. Also, it's possible with traditional Web2 social media through Chainlink functions. So you just need to connect through their APIs like that. But with on-chain stuff, it's much easier, of course. What else? Thank you. It was an amazing session. Thank you very much. I appreciate that. Thanks. Excellent. Thank you. I really appreciate that. So yeah, I'll try to make these medium to advanced sessions, because to show you more advanced stuff, because Chainlink platform is awesome. You can do a lot of stuff. Just we don't have time to show you all of that. But if you like these medium to advanced sessions, maybe even more advanced, just thumbs up or whatever. Tweet me on Twitter. So if you're into that, we can create even more advanced stuff, really more advanced stuff. Okay, cool. I have an error on real estate token and issuer. Please drop the error in the chat so I can help. Is there a Chainlink hackathon going on? No, not. I think the next one will be in spring. So, but don't get me on that. Currently, there is no Chainlink hackathon going on. Just follow our socials, more details there. But I think the next one will be in spring, actually. Okay. This is probably true. It's either imports or optimizer, not run on or EVM version 2. Paris. Slowly, take your time. Just follow the steps carefully, and that's it. Okay. Oh, a lot of questions, sorry. Oh, this is a good one. So I think essentially this question is, what if I have some private data, like API keys or secret or something, or some secrets that I don't want to be exposed? Yes, that's possible. So I'm gonna go to Chainlink docs. Sorry about this. So docs.chain.link, chain functions, guides, and you can see that you can use non-hosted secrets in requests. So first of all, you want to go through this guide to see how you can set up your environment, how you should write your code to consume your secrets. So basically, you can see you have a different function arguments need to be added. So I'm not going to go through all the code right here. It's a bit different, but it's really straightforward. And also, I'm going to scroll up back over here. There is like a secrets management page specifically explaining how to do it and threshold encryptions and all the technical details behind. So you'll want to check this. So essentially, you have two locations to be hosted, remote or non-hosted. Essentially, what you want to know is that you are not like one node in a DON will not be able to see to get the whole secret. So there will be like fragmented in shards for security reasons, and then nodes will need to communicate between themselves to recreate the secret from shard for their execution. And then once the execution of your JavaScript code is done, it will immediately destroy the secret. That's how it's programmed. You can see the source code on GitHub. So this is the extremely safe way to share your secrets. And final thing, after you read all of that, is if you go to supported networks over here, let's go to Sepolia testnet, for example. These are endpoints like don't host or remotes. You're going to use one of these, and that's it. That's how it works. I hope I answered this in a short time frame, but yeah, this is like a 2-minute crash course on this thing. But yeah, extremely great question. This is great. Okay, cool. Failing to compile. Okay, please, again, so when you go to compiler, select 0.8.24. Go to Advanced Configurations tab, open it. For EVM version, set Paris instead of default, set Paris. Click check this enable optimization checkbox and set it to 200 runs. That's it. If you are using Hardhat or Foundry, check their docs. It's extremely straightforward how to turn optimizer there, but you need to turn optimizer. Okay. I'm not sure. I think there won't be a full hackathon. Don't get me at that. I'll definitely tweet if there is one, but I think that's how it's going to be this year, unfortunately. We'll see. But there is a hacker house. So I think more news after the hacker house. I think there's one in October. Maybe you're right. Now I need to double check my info. Sorry for this, guys. But definitely it's on Chainlink social. Okay, cool. Are there internships on Chainlink Labs? I don't know, but we have like careers page on Chainlink Labs, so check that one. Maybe there's more detail there. I really don't know. It'll be cool if there we go. Like, yeah, but I don't know. Okay, I answered this one. Okay, great session. Thank you very much. Oh, good one. That's the address of real estate token.so smart contract. I grabbed a piece of the code from CCIP Bootcamp and forgot to change the argument variable, and now it looks really dumb. Sorry about this, but yeah, that's the one. Sorry. If I want to do this once more, can I just use the same workspace in Remix as well as automation? Yes. You can just repeat the process. You can even use the one that you started. It works fine either way. Yes, totally. Like you can watch the recording of this at your own pace, study. It works. Can I self-host private DOM nodes? No. Oh, this is a good one. Is there a way to provide data from IoT device to smart contracts, but in a decentralized way? And what is the best way to do that? Yes, you can do that actually using Chainlink functions again, because Chainlink functions, where is that diagram? I think it's over here. It's a decentralized, I think there is a diagram somewhere. It's a decentralized way to get off-chain data and computation. And the thing is that because every single node will execute your JavaScript code, and following the previous guide, like question from previous guy for, whoops, sorry about this, for where is that? For secrets management, you can also provide API keys for your IoT devices, like, I don't know, wearable smartwatch if you have and want to connect to Strava API and you run for this amount of kilometers and now you want to have on-chain, to earn on-chain tokens because of that, some stuff like that. So that was like a really cool, actually, project on Hackathon using this thing. You can also go to use chainlinkfunctions.com. And here, if I search for IoT, I think there will be one example or something, or variable Strava. Oh, there is one example. I'll just need to find it. It literally connects to API, to IoT device. It's not technically IoT, it's like a smartwatch, but there should be one for IoT. But yeah, that's how you do it. Like it's definitely possible. All of these examples are really cool because you can just inspire yourself to like have this one is cool, like prompting AI for response to a bunch of different use cases. And of course, if you scroll down all the way here, it's like a lot of examples. You can add example on your own as well. Where is that? Yeah, so you can add your own example. Pretty easy, pretty straightforward. You just open a PR, basically. That's it. Open a PR, someone will review it, and that's it. Oh, this is a great question. Can we transfer private data and message by CCIP? Is it possible to hide it somehow? This is an excellent question. So CCIP sends raw bytes data. So this is chicken and egg problem, I think, on blockchain. But if you find a way to encrypt it and hide it on blockchain, then you can, is the same thing as with CCIP. How to rephrase that? You somehow needs to encode your bytes data secretly, and then on the other side you need to decode it using some kind of key, right? But also this algorithm will be on chain, right? So it's really hard question and really hard problem, but it's hard because of the blockchain, not because of the CCIP. I think I answered your question at least. Sorry, that's the best I can do. But yeah, in theory, yes. In practice, it's not that easy. Thank you for help. Thank you very much, guys, for joining. I'm really glad to hear positive feedback about this stuff. So yeah, we're gonna continue to create more advanced content, definitely. Okay. Oh, congrats. So Roger finished the session early. Nice job. Don't forget to submit your contract addresses via that form after day 2. And if there are like all transaction hashes, as I said already, you will receive on-chain certificate of completion for this bootcamp. Nice job. Thank you for joining us. See you tomorrow. Using chain functions and CCIP, can I incorporate a banking API to convert physical assets into RWA? Yes, of course. Chaining functions allows you to connect to external APIs. Like all the technical stuff needed for this is there. Like you can just connect. Now the only tricky part here is like the ownership of physical assets in a real world. But if that's solvable problem, then yeah, definitely. This is really easy to be done. Yes. So this is live YouTube video. Once we stop live stream, the recording will be immediately available at our official YouTube channel. So if you go to Always Stay Connected here, the second URL, this is the official Chainlink YouTube channel, or just type Chainlink on YouTube, subscribe, and it should be live here. Playlist. I'm too afraid to click somewhere here while to not appear in an infinite loop with live stream. But yeah, it will be available immediately on demand, so you can rewatch it. Yes, where should we submit our results? Good question. So there is a homework page over here. So at the end, so once you have, so after day 2, once you have RWA ending and English auction exercises done as well, so you can click via this form, like submit via this form, all 4 addresses. So just wait for day 2, and deadline is October 4th. So that kind of answers this question. So yeah, I know it's late. You can still complete it. Go back to sleep, relax. You can rewatch the recording if you need it on demand later. You just need to finish all of these 3 exercises, provide these addresses so we can see transaction hashes that confirms that you completed the exercises, and before October 4th at midnight Eastern time, submit via this form. Just click on it, and that's it. It's a simple type form. It's really easy. It takes, you see, 1 minute. It's really easy. Just your email, something, right? test.com, and this is not going to be Ethereum Sepolia, Fuji. But if you have issues with tokens, can be any testnet supported by Chainlink. That's totally fine. Like blockchains are like the host blockchain is not that important because we have CCIP. You can just transfer to whatever chain. It's not that easy. Ethereum Sepolia was the original testnet, but again, look at this fees. It's really high and painful. So I'm gonna just hit back. Thank you. You're welcome. Thank you for joining. What will happen to the title of property? Well, nothing. I excluded that from the metadata because, I wanted to keep more interesting stuff. I felt that the CCIP bootcamp is way harder than this one. When will the next CCIP bootcamp be? Yeah, well, intentional. Because we hosted 4 CCP masterclasses, and we wanted to level up your knowledge to build beyond the simple examples. But if that was too hard, there's also, again, always stay connected, my favorite page. There's also this more beginner-friendly bootcamp in November, so maybe you can join that one. Of course, this one is not that hard because you're just following exercises, but like to recreate or adapt your use case using these contracts, it's a bit harder and a bit more advanced. Not that much, but yeah. When the next CCP bootcamp will be? I don't have exact dates, but there should be another one, CCP Masterclass number 5. So there should be. I'm not 100% sure of that. I want to do it, so follow our socials. I don't have a timeline, but hopefully it will be another one. So yeah, the plan is to have CCP Masterclass number 5. Now when, I don't know really. I haven't started working on it, so yeah, I don't know. Okay. Anything in Chainlink, so multiple RWA contracts are created on the same asset? Well, it's not technically like a Chainlink problem. It's more like a design of your smart contracts, right? So it's a solidity problem. I used factory pattern because it's like probably the easiest one or one of the easiest one. But yeah, technically it's possible. Just design your smart contracts in a way to have multiple contracts for the same asset, and that's it. So speaking of time, we have, I think, 30 to 40 minutes left for the exercise because unfortunately Olympic team will not join us for this session. So yeah, we're just gonna extend this coding exercise part. So yeah, feel free to take your time, finish your homework now while we're on the live stream, and we're gonna have the talk with Olympic team next on the next occasion, next time. Okay, All rocking. Thank you. See you tomorrow. Diogo finished his exercise. Nice job. But again, as I said, we have like 30 to 40 minutes. So we still have time. Nice job, Diogo. See you tomorrow. Thanks for joining. The email I registered with does not have my real name linked to it. How can I get my name corrected on the certificate? I think the best place to ask this question is on our Discord. Just go join our Discord, go to Bootcamp, server, to Bootcamp channel on the server, post this question there, tags us, and someone from the team will provide you more info. We should be able to figure this out. No worries. It's a technicality, it happens. Thank you so much. It was really informative. Thank you for joining. See you tomorrow. Really appreciate it. I hope this was a useful usage of your time. We try to make something a bit more advanced this time. Can we use any API in functions? For example, the API of your own project? Yes. For example, like you can have like your server, your backend exposed with a bunch of stuff, bunch of security measurements you care about, complex logic, whatever, and then you can just have a simple JavaScript code to make API call and get a response, and then pass that response to smart contract. That's preferable way, actually, I would say, because it's like much more customizable. So yes, definitely, it is possible. Thank you, guys. I'll see you tomorrow. I hope. I'm glad to see positive comments. Also, like negative feedback is totally fine. Like if you're talking too fast, or this is too easy, or this is too hard, or like that's all great. We try to listen to your feedback. We always listen to your feedback, and then we try to adapt our content based on your feedback. So yeah, any feedback is appreciated. Okay, cool. See you tomorrow. If there's like more questions, feel free to drop them in the chat. We're gonna listen to this lo-fi music now. And yeah, as I said, more time for exercise because Olympia team will not join us, unfortunately, due to the last minute conflict. But yeah, thank you. See ya. I think I'm kind of like I'm like a host of a radio session or radio show, because like we're listening to music, I'm just talking to you guys. But yeah. Oh, this is a great question. So yeah, so you'll receive your POP on your email address, then you will have a unique minting URL just for you. Don't share it with anyone, and then you will provide or connect your wallet and provide your wallet address, and that's how you will mint it. So we're just gonna provide you with the unique link to mint the on-chain certification of completion. The rest is only. Yes, it's really high. I don't know why. I think it's been like for a week now. As you can see here, it's mostly red. Like, look at this. It is like really high. And you know, when I did some last minute testing last week, I needed to switch to Fuji because like this is ridiculous. But yeah, as I said, like if Fuji is too high or you don't have tokens, whatever, like you can deploy to AMA, you can deploy to Optimus or Sepolia, Arbitrum Sepolia, any blockchain works. Just you need to do these exercise on any blockchain and be mindful of config details. So config details will be different, but you already know that this is a medium to advanced session, so you should be able to figure this out. Thank you. See you tomorrow. Thank you. Great job. Congrats to anyone finishing the exercise earlier. Is there a way to get more for contract deployment? We have our official faucet. If that's not enough, I don't know, ask on Twitter or come back tomorrow because of the limits, or just deploy to other test network. Like, it's really a problem with testnets, not us, sorry. Like, you know, yeah, we try, like, honestly, personally, like, I like to do everything in Foundry because, you know, like, that's how I do the development, but once testing come, you need to to go to testnets. Also, Alchemy has a pretty decent faucet, so maybe try with them. Avalanche should have their own faucet, like maybe try Avalanche official faucet. And yeah, so hopefully you'll find it. Should I create a marketplace for it? For testnet tokens? Please no. If for RWAs, this one, that'll be great, but for testnet tokens, no. Testnet tokens should be easy and available to everyone, easy to get and available for everyone, because it's just for testing purposes. For example, our link tokens like available, like we never had issues with link tokens, right? It's just these gas tokens. Thank you. How to fix? Maybe you can just drop me the URL of your functions request, and maybe I can show you now live how you can debug stuff with Chainlink functions. If you're comfortable with that, just paste me the URL of your function subscription, like this. So functions Fuji, your ID, and then I'll show you how to debug it on Chainlink. Okay. Can I use ERC71 standard? Yes, absolutely. Even like we started with this project for the Block Magic Hackathon, and at the time I used 721, but I switched to 1155 because we can also have like fractional assets, and that unlocks like much more use cases because you can sell the portion or do something with the portion of your real world assets instead of like the whole thing. Like with ERC71, when you transfer the whole thing. With 1155, it's a bit more flexible in that term. So, but yeah, definitely ERC20, 71, 1.5, all possible. Yeah, tomorrow or Alchemy or official faucet. Yeah, we have time until October 4th. So yeah. What else? What is your preferred configuration for ID configuration without using Remix, but through ID with Hardhat or Foundry? I use both, although I like Foundry more. Contract creating code storage out of gas. How much gas it requested for this transaction? It's probably because of the gas issues, unfortunately. Yeah. Testnets are hard. We are trying to deal with them, but yeah, it's not always that easy. All right, we have 20 to 30 minutes left, I think. So if you have any more questions, you can drop them in a chat. I'm here for you guys. If you want to send me that function subscription to enable to debug it, I can show you that as well. Okay, so how do we enable chain? Let's go here. So to enable chain, go to Remix. Let's close this thing. Let's find the enable chain first of all. That's here. Okay, so enable chain function is here. So you need to provide chain selector, grab from the docs, address of token from the docs from you deployed, and probably the error you're seeing is because of the bytes value. So you need to provide the bytes value of CCIP arguments. Now, if I go to, let's say, CLL CCIP Bootcamp right here, we also have like in other bootcamps, and I'll send you the link, but I just want to find this part. The metadata, development best practices, extra arguments. Yeah, here it is. This is the script. So you want to have a script something like this, where you can provide gas limit, for example, like 300,000, and then it will return this extra args bytes. Or if there is a new version 2 of CCIP extra arguments, you're just gonna create a new version to encode and whatnot. Like it's the best practice. You can also see in the official docs that extra arguments should be mutable, right? But essentially you want to provide you want to provide some bytes data. Now, it will look something like this. Let me just find it. You also obviously want to calculate that by yourself, but if I search, okay, so no, sorry, extra args bytes. So where is that value? Yeah, so it will look something like this. So again, you'll need to calculate it, right? Probably is going to be the same. Depends on the gas limit, but you'll just provide something like this to enable chain here and chain selector. And I think that's the reason why we're getting this error. I'm going to share this contract with you. So that'll be extra arguments here. Whoop, I'm gonna paste it in a chat. And you can grab that helper contract from here. Do not deploy it to testnet. Just deploy it to local Cancun environment or Foundry or whatever, because like to save on gas. You can use it as a helper to calculate it. You can also perform this in JavaScript or TypeScript or any other actually language. It's pretty straightforward with the support of API encoding and Solidity. But yeah, hope this answered your question. Oh, yeah. I'll try to top it off. I don't know if I have any, but yeah. I'll try. If not, maybe try some other testnet. Yeah, or a fork, or yeah, we'll figure that something out. You can always ask us on Discord. There is a Bootcamp channel. So you're welcome. All right, let me grab some water. I'm really thirsty from all this talking. You can find the link to Discord over here, or as I said, where is our Bootcamp? Where is our Gitbook? It's over here as well in Always Stay Connected page. Is this a bit bigger? Yeah, let's zoom it out. Okay, cool. So yeah, you can ask questions there. Cool. We're still gonna play some lo-fi. Once you're done, make sure to save your contract addresses because you want to submit them tomorrow after day 2 for homework using that type form. Yeah, as I said, if you have questions, drop them. If you're done, also say that so we can maybe even finish this earlier. Depends if already done, but if not, like we still have plenty of time for you to complete this exercise. So do not hesitate to reach out. Don't be shy. Ask questions. I mean I have time to even help you with debugging of functions part and show you some debug tips and tricks or whatnot. So anything related to Chainlink, tokenized real world assets, or Solidity is a good question. I'll help you. Thank you. See you tomorrow. Congrats, Mauricio, on completing the exercise for day 1. Nice job. And yeah, questions about music are also welcomed. We'll try to accommodate your requests regarding music. I think this song is pretty popular, or this mix. So, yeah. I'm gonna mute myself for a minute. This is an excellent question. How proof of reserve can be valuable for this use case? Yeah, so for this use case, we are using this update price details smart contract to, to get price details of real estate using functions, and we're calling automation to automate the calling of this function and whatnot. Like in reality, if you have like real world asset and you want to use it in DeFi or whatever, then you can just use, instead of this mocking thing, at this point we'll use proof of reserve feeds. We'll have a feed for our reserve, like our real world assets, and then like the usage is extremely straightforward. Like if you go to data feeds, there is a section of proof of reserve feeds and different types of it, and the usage is pretty much the same as with data feeds, so that's like extremely straightforward. But here we can find the addresses of proof of reserve basically, and yeah, for this purpose we will use proof of reserve feeds instead of like, a bunch of reserves there, instead of like me pinging functions for price details. But it's like a mock property, so that's why. Okay, nice. Someone topped up faucet. Thanks team, to whoever did this. That wasn't me. I was live on stage with you sharing my screen, so that wasn't me. But yeah, thanks to whoever did this. Thank you. Yeah, I know there is an issue with testnets, with bots. I don't know why people are constantly spamming faucets for all different testnets from all different, like, I don't know why. But yeah, that's why there's all those limits, unfortunately. Not just our faucet, any faucet. Like Alchemy has a good faucet as well. Tried that, they're decent ones. So yeah. No, like you can if you want to practice, but I didn't do it on live, so you don't have to do it. If you want, you can, but it's not like hard requirement since I didn't do it. Okay. Oh yeah, this is important announcement. So if you join today without registering through Luma, just popped up on YouTube and watch it. Please register in order to receive following communication. Like next steps, a bunch of, like if you participate in other bootcamps, it's a pretty standard flow. But also like for homework, for certification of completion, all that stuff. So please do not forget to re-register. There is a URL on our socials for Luma. Oh, nice! Congrats! All done. Congrats, Fractio. I hope I pronounced that correct. It's so yeah. Nice job, and see you tomorrow. And save these addresses so you can submit them after day 2. Nicely done. Congrats. Okay, this is great, unexpected feedback, but I love it. So Valerio said, I finished a while ago. Congrats, nice job on that. But I'm enjoying following the stream as other users are asking us some questions. That is true. There have been some great questions. I do feel like I'm a radio host or something, or like Twitch streamer, because like I'm just talking with the music in the background. But yeah, this week has been fun. And as I said, you can ask me anything about Chainlink, Solidity, tokenized real world assets, even music. Don't ask questions about faucets. That's a painful problem that no one is able to solve yet. But yeah, we're doing our best. Cool. Thank you, JJGGU as well. I think I pronounced that correctly. See you tomorrow. I pasted the CCP router address to functions router address in the Git book. Oh, okay. So functions router and CCP router address are not the same. So if you go to where is functions.chain.link, here on the home page, there is a functions router, this address. So this is not the same router address as CCP router. So grab it from here. It's a different router. Different router contract, different address. So yeah, be careful with config details. Okay. Obviously, you can just grab them from docs. Where is docs? So there'll be Chainlink functions, supporting networks, that's Fuji, Avalanche Fuji testnet, and here's the function router. So A9D58 and the rest. Okay. Cool. Let's see how we're dealing on time. I think we have like 15-ish minutes left. So yeah, for the exercise part. So that should be more than enough to finish. Of course, if you cannot finish because of the testnet issues and like other stuff, there's still time until October 4th. You can always revisit tomorrow. Basically by the end of this week. So yeah, you can also ask any follow-up additional questions on Discord, or while I'm here for the last 15 to 20 minutes here with this beautiful music in the background, you can also ask questions directly in the chat. Just drop them. Let's go back to this page. Yeah, and just a reminder that SmartCon is soon in Hong Kong at the end of October 30th and 31st. But if you are around in town, there is a hacker house 2 days earlier. I won't be there in person. I will be, as I said, virtually online, helping and mentoring. There will be some other folks. I don't want to say names, so you can. But yeah, some people that from the developer relations team that you interacted before and love will be present there in person. But it's gonna be a huge event. There will be even I think there will be some interesting. Yes, there will be certifications. So yeah, that's what I want. Like, there will be certificates. So yeah, that's kind of interesting. So yeah, try to earn your certificates today as well. There as well. There will be talks, workshops, of course, and specific courses regarding certification. So that's new thing compared to previous hacker house. There will be also talent. Yeah. I want to participate in that one, to join that one. And on day 2, there will be actually there will be like certifications exams in person. So you can earn your certification there by completing the exam of blockchain fundamentals and Chainlink fundamentals. So it's like fundamentals certifications. It's not that hard. You'll figure it out. You'll learn it. But maybe if you're up for that, maybe you can provide me some feedback there. Maybe we can create some extremely advanced, like top professional level certification. That'll be like hard to get, but like we'll prove you that you're like the expert in the field. If you want that, like drop feedback in the chat. Maybe we can think about that maybe for next year. We'll see. Of course, there's lunch, more workshops, in real life exams. That'll be fun. I'm sorry I'm gonna mix that in person, but yeah, that should be like pretty cool. So yes, subscribe for that. You can get your tickets there. Let's see. And of course, for the main SmartCon conference, here's the list of speakers and homepage and how to get tickets. And SmartCon should be really fun. There is a developer pass, so yeah. Okay, nice learning experience, buddy. Thank you very much. Whoops, no. Yeah, this one. Thank you very much, and see you tomorrow. I'm glad you enjoyed this. Okay, this is an actual question. How we can prevent minting the tokens of individuals who don't actually own the underlying physical asset? And if we go back here to this page, step number 4, the issuance part of tokenizing a real world asset, that part is out of scope for this bootcamp. And yeah, there is, like, it's a hard problem, but like it's not that of a technical problem. So like probably another industry. So yeah, but it's out of scope for this bootcamp. Okay. Will you be in Thailand for that one? I don't know. I don't know. Maybe not. We'll see. Thailand is there's still time. Oh, great question. If we do the project on other testnet than Fuji, whatever, do we still get a certificate of completion? Yes. Just whatever testnet. Again, just make sure, if you go to docs, to quick links, if you click here, just make sure that CCIP data feeds, functions, and automation are available on that blockchain. On that, like, that'll be Arbitrum, Avalanche, Base, that'll be Ethereum Sepolia, but not with these fees. There'll be Optimism Sepolia, Polygon, like all of these are like supported, deploy to them, 100% you'll do it. So just deploy there and do the actual exercise. So just one transaction, deployment transaction is not enough. We need to see, creating a function subscription, creating an automation subscription, calling the issuer and all that stuff. And, like that's enough. Definitely, I'll write that down on a Discord as well, because of this issue with testnet tokens, whatever, any blockchain works, Yes, 100%. I hope that is clear. I got too excited. Sorry. This is an actual question. What happens if A transferred to B 10 tokens from Fractionalized to a different chain, but the rest of the tokens remain on the origin chain? Will CCP keep track of that? With this current implementation, like, it won't, because it's like extremely simplified, but that's definitely possible. That's definitely possible. So, like, it's just a matter of like, CCP itself is just an messaging protocol, an interface for transferring messages. You are in charge of developing smart contracts for that. But yeah, definitely possible. Maybe we can do that for next bootcamp. Yeah. But with the current implementation, you will be aware of a supply on that chain, if that works. Yeah. Voice is gone. I hope you can still hear me. If not, please drop something in the chat. I see I'm not muted. Yeah, I'm not. Okay, cool. We're almost done. We have 10 more minutes. I'll be around for 10 more minutes, definitely until the end of the stream. If you have any final questions, drop them in the chat. If you can hear me, please say that in the chat as well. And okay, it went for a moment, but your voice is back. Thank you very much, Javier. Thank you very much for the feedback. I'm literally all by myself. So yeah, in the room, like, physically. So I cannot, I'm not watching the actual stream. So thank you for that. If you have any final questions, I'll try to answer them. Also, if you have any follow-up questions that you forgot, tweet me at AndreiDev, or join our Discord, even better, and join the Bootcamp channel on Discord, and I'll try to answer that there. And yeah, of course, you can always connect with myself and Richard using Twitter or X. I still calling Twitter. X for me is like, I don't know. I used to, like, I'm still saying, like, I tweeted that, like, I X that, I posted that, like, it doesn't feel natural to me. So it's still Twitter for me, but yeah, on that platform. Okay, thank you for the feedback about the connection. Thank you very much, guys. And yeah, thank you, YN West, I pronounce that correctly, for joining. See you tomorrow, and glad to see that this was a useful usage of your time. Okay, I think we have 10 more minutes. If you have any final, any last questions, feel free to drop them in a chat. Thank you, Rocio, and see you tomorrow as well. Thanks. Okay, I'll just gonna. Wow, there's like a lot of messages. I just popped into the Discord. There's like 79 messages for me to review. So I'll try to answer them as soon as we end up this stream, because this stream is obviously has a higher priority. Yeah, I'll follow up later. Thank you very much. See you tomorrow, guys, where we're gonna use this tokenized real estate contract and plug it into two different use cases. Thank you very much. Flip Dream Space music to call me online. Thank you, Tivo. See you tomorrow, man. See you all tomorrow, guys. Can you please tell me how to learn Solidity properly? That's an excellent question. I need to think about it for a bit. Properly. Thank you, Alina. See you tomorrow. Thanks for joining. Okay, first of all, there needs to be a couple of aha moments that needs to click. And I'm a huge believer of like hard work. So if you spend 10,000 hours doing something, like working on some skill, eventually you will figure it out. Sometimes you'll just got unlucky and you'll spend some hours doing some unproductive work, but that's how it is. It's like a scarf, and it is what it is. But eventually it will turn out. So first of all, Solidity documentation is really good. So Solidity docs is really great. Read carefully, study carefully. This is a really good piece of content. Like, it's really great. Some knowledge of like general computer science is also needed, like understanding stack, state machines, what else? Heap for memory and stuff like that. So that's extremely important. Then mastering the EVM itself. I don't know if they have here EVM or okay, let's see. EVM Ethereum. So mastering Ethereum virtual machine is crucial. So yeah, there are some all of this, like from these diagrams you should know, like not this briefly, like in depth. You should be familiar with it, because essentially you're programming EVM, like instructions from EVM. EVM is also easy to learn through languages like Yule and Huff. So EVM.codes is an exceptional tool for understanding EVM, and they have even this nice playground. So you can literally just use bytecode and like literal opcodes, like for example like this. Where is it? It's reproducing playground. So you can just play with with mnemonic and see what's going on here. So understanding the EVM is crucial. And finally, understanding the blockchain UR itself. So mempools, proof of stake, proof of work, how that affects you, all of this tiny stuff. So that's how it is. And yeah, this is like a shameless plug, but also there is like smart contract design patterns newsletter. Oh yeah, yeah. This is my newsletter where I'm talking about smart contract design patterns. So for example, I don't know, you can subscribe here. There is 100%, like 90% chance that you'll at least one call transfer from function or ERC20. So it's not that easy. Like naive implementation will be something like this, like transfer and mint and burn tokens. Like for this use case, there's like so much more stuff that you need to take care about it, and you need to think about it, and like this is all Solidity code, so technically like you'll expand your Solidity knowledge there. But Solidity really follows the Pareto principle, like I don't know, like 80-20 or 90-10. Like 80% of language is extremely easy to learn. It's really, if you know, like if you know how to read or write JavaScript, it's really, or C, have experience with C or C++, it's really easy to read and write the code. Like it's really easy to start, but to master that final 10 or 20% is like, it's hard. So yeah, mastering topics like this is crucial. And finally, just code. I'm a huge believer in 10,000 hours. Just code Solidity for 10,000 hours. Deploy to testnet. Talk to people. Try asking people to break it down. Ask community. Like learn, read. Like yeah, eventually it'll click. Yeah, that's my final advice. I don't know. Okay. Is it okay to use Solidity 27 in hardhat? For this bootcamp, I used strictly 0.8.24 because I think it's a nice Solidity version with transient storage and whatnot. So try hardcode to 24. That should work. Can you please drop the issue in Discord, because we're approaching the end of the stream, and I'll follow up there. Make sure that you follow the steps carefully, and try maybe tenderly to see what's the issue with the error. But yeah, I'll try to help in Discord. Can you please drop the URL to your function subscription? So this page, so I can go to this part and debug it for you. So just this URL in Discord, and tag me. I'll try to follow up in the next, I don't know, until tomorrow, definitely. I don't know JavaScript Python cannot directly learn Solidity blockchain. You can, but I don't advise to. Solidity is like a very specific language for a specific purpose. It's not like, it's not like with JavaScript or Python. You can write code bases for different purposes on different platforms. Like Solidity is very specific. So I suggest first to go with some other language. Like, I don't know, I started with C and C++, and Solidity reminds me a lot of C under the hood. Syntax, like sugar-wise, is like it's like JavaScript, but under the hood, like to master this, like short answer, learn some other learn some other programming language first before Solidity, because it's like really specific to the blockchain platform you're on. Okay, cool. Fail to decode the output data of the bonds. When you call the issuer, the issue function. If you can please just drop me the failed transaction and this error message again to Discord. Sorry, because I cannot debug it like this. I should be able to help. I'm not sure. If you can drop a screenshot to Discord or something. Yeah. I'm not sure where you find this. Sorry. Okay, we're right on time. Let me see. I'll just stop the music. Okay, cool. So that's it. We're approaching to near the end of this first session. Our time for like exercises expired officially, but as I said, you can just follow up on Discord. I'll try to be as supportive as possible for tomorrow to answer all of these questions by tomorrow, so you can be prepared and ready for tomorrow's session. Thank you again for joining us. Thank you for all of you that stick all of it until the end. I see more than 100 people are still watching the stream, so that's amazing. I hope this was useful for you. And yeah, see you tomorrow. Well done to everyone completing the exercise. And yeah, do not forget to save your contract addresses, because you will need to submit them eventually for the homework after the day to earn this certificate, on-chain certificate of completion. Once we end this live stream, the YouTube video will be available afterwards for you to re-record it and skip at your pace and rewind and whatnot. So yes, video will be there. Thank you guys, and see you tomorrow.